In mathematics, anything power 0 is 1. But in this automated theory, it's a number of copies. When I put 0 power 0, that means there is no copy of 0. 0 power 1 means 1 copy of 0. So this says that the n and m can vary from 0 onwards. When n and m both are 0, 0 power 0, that's nothing. Then 2, 1 power 0, nothing. That means the symbol 2 alone. When n is 1, but m is 0, 0 power 1, 2. That means 0, 2. So this set indicates collection of strings of the form 0, 0, 0, 0, 2, 1, 1, 1, 1, 1. 0, 2, all possible strings of this fashion. Okay, I call this a set. Now, if I want a machine which can scan one string at a time and say that yes, this fellow belongs to this family. So I am designing a small machine like this. The machine behavior is like this. If you have a state called Q1, another state called Q2, this is how you start the process. As long as you scan a 0, it can remain the same state. The moment you scan a 2, it goes to another state. And you can scan a number of ones. And wherever you have double 0, double circle, there's a stop state. So, I'm trying to design a small mathematical machine model that will take input of this language, this set, one word at a time, scan through the word. At the end of scanning, the machine will say, yes, it is accepted, or no, it's not accepted. So my job is to make a simple mathematical model which can scan through the given word. Only if the word is in that set, it will accept, otherwise it will reject. Why should I make an attempt like this one? Because in mathematics, when solving problem, we put them as a word statement. Suppose I want to solve a differential equation. What do? I write that. I make a lot of sentences. I may use symbols, expressions. Basically, the problem I'm writing is has a lot of words. So when you read those words, you understand that it's a differential equation of first order or second order. So everything is in words. And once I read all those words, I understand that this problem is from OR, this problem is from PDE or ODE. And if you know the method of solving, you can solve it and give an answer. So the idea is, the machines are made to read all the words. After reading all the words, the machine will understand, oh, this problem belongs to PDE or ODE. Actually, I can solve that. It will solve and give a solution and then stop. This is what the computer does. You write a program, you feed the data, the computer goes through the series of statements, it understands, it solves and gives an answer. So we are trying to develop a machine which can read all the input data, sentences, understand, solve and give an answer. So here the first attempt is to make a simple machine model which can take any input from this language, this set, run through that one. At the end, you can say that yes, this word is a valid word, this word is not a valid word. So how do we understand that? If the machine is running from the start to the end flawlessly, at the end of scanning the entire word, if it's reaching a very special state called final state, then the word is to be accepted. Listen carefully. I'm giving one word from the set. The machine is supposed to scan from left to right the entire word. At the end of scanning the word, the machine should be in a final state. So here, I'm given a word 0021. Do you think this word 0021 is in this set? Yes. How many copies? How many zeros are there? 2 zeros. Then a 2. And how many ones are there? Only 1 1. So this word, this string is part of this set. When n is 2, m is 1, it is 0 0 2 1. So this fellow is very much member of this set. I want to check a machine. I want to set a design machine which will check on this input, given input, run through and say yes, this fellow belongs to this set. So how will that function? Let's see. but I have a machine in hand. So I place the given word on the input tape. This B all blank, 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 all is blank. Now the machine is set to start. It says that there is a state Q0, state Q1, which is the start state. On scanning 0, it can be in the same state. Look at the picture. Q1 and Q2 are the two states. Q1 is the start state. When the machine begins, it has been some start state. Then as long as it reads the 0, it can remain the same state. The moment it scans at 2, it changes the state from Q1 to Q2. And as long as it reads 1, it can remain the same state. At the end of reading the entire word, the machine is supposed to be in the designated final state. Here, Q1 is the final state. Let's run that. I am setting it. Now, the whole thing is set. The machine is set to start. Run on the given word. I have put 0021 on the input tape, setting the arrowhead on the first leftmost symbol. And the start state is Q1. That's what we are told. The incoming arrow says that this is where I have to start. Now look at carefully what happens here and here. It is scanning. Because it is in state Q1, scanning 0, it is allowed to be in the same state now. Now it is scanning 2 and in state Q1. Whereas Q1 scanning 2, it is supposed to change its state to Q2. Look at carefully. You are supposed to look at here and here. Did you follow? I just do it from the start. Starting. Now it is state Q2 scanning 1. Yeah. So at the end of scanning, the machine is in state Q2, which is called a final state. It's already designated as a final state. That means this word makes the machine move from start state to final state flawlessly. That means this word is part of the given set. Let me take a word which is not there in the set. What happens? What about this word? 0020. Is it there in the language, the set? No. We are supposed to have many zeros, then 1, 2, and then many ones. But here, I am given 2 zeros, a 2, and then a 0, which is not there in the set. Let's see how it functions. Now everything is reset. It is running. Now it is state Q2 and is scanning a 0. Where the state Q2 for scanning 0, nothing is mentioned. It is not defined. So the machine is still waiting for a command from the control. The control has nothing to say about that. That means the machine is unable to complete the reading. It's like a computer hanging. Something happens and the machine is not responding at all. The same way here too. So this machine is unable to complete the process because the machine is not designed to accept this strange word. So if you give any word from that set, the machine can run through, stop flawlessly, and accept. If you give any random word outside that set, the machine cannot come to a halt. So FSA is a machine, a simple machine, which can run through the given string or a word. Only if the word is the assigned set, it can run through and finish flawlessly. If the word given is not in the set, the machine cannot reach the final state. It cannot finish the reading. Okay. So now what happens? This word is not in that set. Now what do? I change the set to a different set. 0 power n to 1 power n. What about this set of words when n is 1? If n is 0, I have 0 power 0, which is nothing, no copy of 0. Then 2, 1 power 0, that means no copy of 1. So when n is 0, I mean the string just 2. I use 3 okay. 0 power 0 na 1 சொல்லணுமே அது வந்து math arithmetic ல இங்க வந்து the numbers are the number of copies So when n is 0, 0 power 0, 2, 1 power 0. That means no copy of 0, 2, and no copy of 1. I mean just the 2. When n is 1, 0 power 1, 2, 1 power 1. That means 0, 2, 1. When n is 7, 0, 0, 0, 0, 0, 0, 0, 2, 1, 1, 1, 7 ones. So this set refers to all the rest of the form 2, 0, 2, 1, 0, 0, 2, 1, 1. So the number of zeros and number of ones are always the same. Okay, now I want to check whether my machine, the previous machine, can run here. If you try that, it won't run. Because this set demands something more. It says that when you have 7 zeros, you should have exactly 7 ones here. If you have 10 zeros, you should have 10 ones there. So this set demands something to memorize. I have to have a machine which can keep in mind how many zeros I have scanned and then once I have to scan further. That demands some memory. And the FSA that I have shown has no memory. So the FSA machine cannot accept this kind of words or set. That means this machine model is not capable of having such set. It has limitation. So we find that for lack of memory, the FSA machine will not work good. So that makes you to think, how about thinking machine with memory? Yes, it is possible to think of a new machine, a better machine than FSA, built with something called stack memory. That we call push down automata, PDA. And that machine can easily handle such sets because it can memorize how itna 0 itna 7 can or 2 itna 1 you can keep a track of what's happening. Then again the PDA will have its own limitation. Appointment oh the version cycle orada will enhance that. They developed another machine called linear bounded automaton. That was easily functioning. Any hard set it was functioning. Then again, they found a limitation. Then they went for a machine called Turing machine. Very powerful. Whatever FSA could not handle, whatever PDA could not handle, whatever LPA could not handle, TM could easily handle. So what about this machine? Is it only certain ma? Yes. There are some sets or problems even a Turing machine cannot handle it. Then when we develop a powerful set, unfortunately, in the Turing computing, we could not develop any powerful machine than Turing machine. That's understanding. You FSA பண்ணுங்க, PDA பண்ணுங்க, LBA பண்ணுங்க, Turing பண்ணுங்க. அதுக்கு மேல we are unable to think and develop a machine more powerful than Turing machine. That's a challenge. Therefore, in the Turing computing model, we can go up to Turing machine model. That's why we are thinking of unconventional computing. We look at nature. Will nature give some idea for us to go build a powerful machine like Turing machine? Okay, why we change our thinking from Turing computing to a different unconventional computing? That's the reason. Because we are tied up with the limitation of Turing machine. Now, a computer like very good computers, but they also have the limitation. Now, let's see how a Turing machine works. I gave you a sample of a simple FSA. I'll tell you how a Turing machine works. So, I am same like FSA, or input table, control table, arrow table. In what way the system FSA? We make some allowance on the arrowhead. And notice in the arrowhead, this arrowhead, FSA right was just jumping one side to the right side. But here, it can jump to the right side, jump to the left side also. It can scan, it can erase the symbol, it can rewrite the symbol. So we are giving a lot of freedom to this arrowhead to jump to the right, to the left, to stay the same cell also, scan the cell, erase the cell, rewrite the cell. This allowance to the arrow makes the machine so powerful than FSA, PDA, and LBA. Is that a computer? Turing machine is a simple mathematical model of a computer. So I want to don't worry about this. This was state diagram. On the tape, I am giving there are blank, blanket, inga blanket. Inga pathina 1, 2, 3, 4, 5, 6 AA portion. Okay, can you show me number 5? Can you show me number 5? Anji, can you show me number 5, please? English math and English, yeah. Madam, you teach math, why isn't it? Yeah, can you tell me, yeah? Anji, yeah. Please. You are showing 5 fingers. I want to see just a 5. If you write this way, it's Arabic numeral of 5. If you write like this, it's a Roman numeral of 5. You can see 5 apples. You can see 5 fingers. You are showing this a Roman representation of number 5, not a 5. So Arabic or Roman, Tamil and Anjik, you can never. This Arabic numeral of 5. So we can never see number 5. Very unfortunate. We talk about all the numbers. We only the same way. How will I tell computer the number 5 or number 6? So I have to communicate the way machine can understand. Maybe I will say, suppose I write 6A, that means 6. So here I am trying to communicate with the machine. If I write 6A, that means RL. If I write 10 A's, that means 10. So this is the kind of protocol I make up with the system. So here I want to compute the function f of x equal to x plus 2. X input, x plus 2 output. If I give x as 5, answer is x plus 2 7. If I give x as input as 10, answer will be 12. So how will I make a computer, a Turing machine, to solve this function? Simple. I have a machine which is called PM, Turing machine. I have a problem. I want to find the value of f of x equal to x plus 2. I will give x, input x to the computer, the machine. It is supposed to solve and give me the value f of x. But how will I communicate that I give 5 or I give 7? So I tell the computer, you have an input table, okay? In that, if I want to give a number 5, I will put 5 A's consecutively. Your job is to scan the 5 A's, do something, and give me the answer. If I give 5 A's for 5, the machine is supposed to respond to be 7 A's, because 7 is the answer. If I give 1000 A, it will give me 1002 A's. So the point is, how will I educate the Turing machine to make the 5 A's into 7 A's? How will I educate the computer, the Turing machine, to scan the 1000 A's, but do something and make up 1002 A's? So solving the function f of x equal to x plus 2 would mean, given whatever is the number of A's, the machine is supposed to add 2 more A's and stop with that. If it has to create 2 more new A's left. So the idea is the machine is supposed to scan, and then once it understands the number of A's, it has to make the 2 blanks into A's and then stop. This is one idea. So this I have to educate and then give us a set of control statements. So I want to give the input x and compute the function f of x equal to x plus 2. I have already given these are the control rules. The idea of making 2 more A's I am putting as these command rules. We need not go to the details now. Look at that, how the machine is functioning. So the machine set input is put at the input A or A put on control this arrowhead can scan, move left or right, erase, rewrite. It is scanning. If I have a blank over there, then what happens? Look carefully. Look at here and here. reached the state Q2, which we have already defined as the final state. So, where it is reaching to a final state. A simple idea how we consider a machine model to compute the function f of x equal to x plus 2. Suppose I want you to kind of think of a machine to compute f of x equal to x plus 3. Enabling here, it has scanned all the A's. Next, moon blank and A, it has to stop. How to compute f of x equal to x minus 2? Suppose 10x இருக்குங்க 10x வாசம் முடிச்சதுக்கு அப்புறம் 10a முடிச்சதுக்கு அப்புறம் will come back or a blank ஆகிடும் அடுத்த a blank ஆகிடும். So it is possible to think of f of x equal to x plus k, f of x equal to x minus k. We can think of now. How about adding two random numbers? How to add x plus y? Here is a simple example. Okay. 2 plus 3 எத்தனை 5 5 plus 3 எத்தனை 8. So I will tell the computer, the machine, that I will give one number, then I will say something and then the other number. 5 3 எத்தனை 5 னு 5 புரிஞ்சுக்கோ 3. So just know that next is the second number. So I have to develop a protocol. So here I am using protocol. I might use இப்போ 2 plus 2 2a போடலாம். Then I use some symbol called p, which I have already educated in the machine that if I enter p na plus output to go. I'm educating. Then I put 3 a's. That means 3. So here I have made the rules or the commands as 5 important steps. Now the machine is supposed to scan the a's and then the p and then the a's. 2 plus 3 வந்து என்ன பண்ண 2a ஒரு p அப்புறம் 3a அப்புறம் blank blank ஆகும் இல்லையா. ஆன்சர் வருது 2 plus 3 5. So I'm supposed to look for 5 a's and no p in between. So how will I educate the machine? I tell the machine you scan the first number அப்புறம் p இருந்தனா அந்த p எங்க a ஆக்கிடுங்க. Then read the next number. The last a blank ஆகிடுது. புரியுதுங்களா? 2a ஒரு p அப்புறம் 3a இருக்கும். முதல்ல 6 ஸ்பேஸ் இல்லையா? அந்த p வந்து a என்ன ஆகுது 2a அப்புறம் மூணாவது a அப்புறம் 6a இருக்கு. So கடைசி போனதுக்கு அப்புறம் the moment you understand the last a, make it a blank. அப்ப 5 ஆயிடும். This is one idea. There may be many other ideas to make 5 a's. So this works on the first idea. How it works? Let's see. So it is said you are supposed to look at the arrow here and the state also. Look at this one. Scanning, jumping. Go பாருங்க. And be if it is just jumping off but doesn't stop. In the point it senses that it's the end of the string and then it jumps back and the area flying. Then now it has reached Q3, which is the stop state, finally. So the job is done now. So given a function f of x comma y, x plus y, that's the idea behind. Any number of x, any number of y you give, it works. How about a function f of x comma y equal to x minus y? I can think of. If you can do plus minus, you can do product and division. When you can do plus, minus, product and division, the 4 basic arithmetic operations, you are making it. In fact, any mathematical equation or formula with a log or exponential or trigonometry, all will boil down to the basic 4 arithmetic operations. So, any big computation ultimately relies on these 4 basic arithmetic operations. And you've already given a machine that can do addition, subtraction, we can do it for product and division. So a arithmetic machine can very well solve a problem which involves plus, minus, multiplication and division, which means you can build on any big problem. So this is the way arithmetic machine is working. But as I already told you, there are problems which are beyond the capacity of Turing machine. That's why we talk about problems can be solved easily. We call them polynomial time problems, P problems. Easy. Any machine can handle. Then there are problems which are beyond the scope of computers, Turing machines. We call them NP hard. Then there are problems which can be verified, but to solve it takes a lot of time. Yeah, to solve now is easy to verify, but a solve it takes a lot of time. So we call them P, NP, NP hard. Something in between called NP hard. So this is how we classify the difficulty of problems. Our aim is to find a machine model which can deal with these NP hard and NP complete problems. Now, இதெல்லாம் நம்ம easily handle பண்ணலாம் with modern day computers. To deal with NP complete and NP hard problems, we do not have good computers. That's why we have go for unconventional computing method. So we look into living cell, how it works. ஒரு செல்லுக்கு என்னெல்லாம் இருக்கும்? நியூக்ளியஸ் இருக்கும், சைட்டோபிளாசம், மைட்டோகாண்ட்ரியா, நிறைய ஐட்டம் இருக்கும். Each thing has its own specific function. And a cell has a lifespan, maybe 2 weeks or 2 months. After that, it is dead. Maybe it divides to 3 or 4, it dies. நீங்க பிறந்தபோது நிறைய செல்லாம் இருக்கும். ஆனா இப்ப இருக்கிற செல்லுக்கும் பிறந்தது இல்லை. Many times the cells have, but somehow உங்க ஜாடம் வரவே இல்லையே. How is it possible? Maybe you are 20 years old. And 20 years எத்தனையோ முறை உங்க செல்ஸ்லாம் வந்து டை ஆகி போயிருக்கும். But you look the same. So what is happening to carry on the features? So each cell is passing on some information to the next generation. Though they divide, though they die, they pass on information. So what's happening inside a cell? So there are so many small things, very minute, but they are all doing some function. So each cell can be seen as a factory, or each cell is doing some computation, some job. So in mathematical terms, we call them computation. Okay, taken a cell, there are some fundamental features. They are, a cell must have a cell wall. We call it membrane. On the cell wall, nucleus இருக்கும், Golgi இருக்கும், நிறைய இருக்கும். So each thing has its own cell wall. So when you take a simple cell, it's made of many membranes. Outer membrane, inner membrane, so membranes. So membrane is the feature that we have to keep in mind. And then there are chemical compounds, there are many compounds inside. Enzymes, fatty acids. So each will have its own component, elements. We call them multi-set of chemical compounds. And then the cells will break down the enzymes into smaller chemical, absorb them as nutrient, live, and then it may flush out some of the waste. So some processing is taking place. For a cell to live, it must have its nutrient. So it will get the nutrient from the blood vessels, from the oxygen, and it processes that nutrient. Then it's absorbed, some waste is flushed out. So something is being processed. So a living cell will have 3 main features: membrane structure, chemical compounds, processing rules. These 3 things were understood by Mr. George Bond, and then he came up with the idea of computing cell. If you look at cell wall under the microscope, this is how it will be. Cell wall is made up of 2 layers of proteins and fatty acids. Gap இருக்கும். And the cell wall will slide over. So they pass on the nutrient to the neighboring cell. Suppose you are not well, you have some temperature, the cell walls slide and they close all the channels so that any virus will not enter into the cell. So they can regulate the movement of membrane, the wall. So such a tiny element, cell, but it functions like a big factory. It's a wonder. We really puzzle how it's happening. They don't study basic mathematics or advanced mathematics, but they function flawlessly. So this functioning of a cell is understood by George Bond. membrane structure. They have a lot of molecules, chemical compounds, and there are a lot of activities, processing happening. I'll quickly pass on. So, inside a cell, there's a life because it's living. It is based on the biochemistry and the membrane structure. So, to put it simple, a living cell is a small factory where a lot of chemical processes take place, governed by the membrane, cell wall, nucleus wall, Golgi body wall, vacuole wall, all they just pass on information. They keep. So this is absorbed, and you are ready to think about some mathematical model. We won't call it cell anymore. We call them computing cell. We don't call them enzymes or protein. We call them multi-set. We don't call them chemical process. We call them rules of process. Okay. So what is a multi-set? It's an object with multiplicities. Look at this one. CABB. It's a word or a string. Already now we word and also yeah. So you are not familiar with the term word or a string. Here this is a word of length 4. Why length 4? There are 4 symbols. CABB. I can say CAB power 2. 2 copies of B. The C could be, A could be some chemical compound, B could be a chemical compound in 2 proportions, and C could be a catalyst. So we are trying to express the content, the chemical content like a word. We are trying to express in terms of string. Okay. And the processing rule. Suppose I have this string. I want this string to be changing into different string. Let me this enzyme. Sometimes the enzyme is broken into smaller chemical compounds. Something is changing. That's because of process. So I want to talk about the processing. Look at this thing. Here I have something called a multi-set, CABB. This is the processing rule. If you find CABB, after some time, it should change like this. Probably this is a rule in a living cell. It says that the C remains a C, A becomes 2 copies, B and D, they change their format to D and D. D and D. So the B has become D, but if you put an outer way intake, that means this D will be sent out from that location, and this D will be placed inside a room called 3. So this processing rule is making C as C, A into 2 copies, this B and B as D and D, and sending them to different places. Probably this D is a waste, so this is being flushed out. That's the idea. Suppose there are many such processing rules. We want to give priority. So we bring in some priority operator greater than. That means suppose there are 2 different rules, rule 5 and rule 3, and I want to give priority for rule 5, I can indicate like this. So we gradually bring in the mathematical elements into it. Greater than, less than, bring in. Okay. Look at this one. Here CABB, CAADD, that's a delta, which means after the rule is finished, the entire membrane should be dissolved. That entire rule should be dissolved. Wherever the processing rule was happening, that region will be disappearing. Because cells have a different lifespan. Sometimes the cells die, they are not there. So the trying to capture that with the help of a delta notation. If the rule has a delta, that means that whatever the membrane will disappear. The same way, we can think of making that reverse. Something happens to cell and cell wants to tighten up, want to get stronger. So we bring something called tau. If a rule has a tau, that will strengthen the wall gets thicker. So it is possible to define some mathematical operations so that I can get the idea from the nature, the cell, but I can make it more mathematical. So as long as you get the idea from nature, that's fine. After which we make it more mathematical. All we want is idea. Once the idea is given to us, we make it more mathematical. Right. I'm just trying to draw a mathematical Venn diagram-like structure of a cell. I told you already, mathematicians will always take everything into mathematics, whether we study biology or economics or commerce. We have to put them as numbers or expressions or Venn diagram. So a cell structure is drawn like this. Probably the number 1 is the outermost cell wall. Maybe this 8 is the nucleus. So I'm just trying to give a Venn diagram representation of a cell. And then I give a tree representation. That means the number 1 is comprising everything, the cell wall. I put it here. Inside there are 2 large sections, room 2, room 3, and room 4. That means 1 contains 2, 3, 4. So I just draw them as such. 2 has nothing inside. 3 has nothing inside. Whereas 4 has room 5, room 6, room 7. So room 4 has 5, 6, 7. So I'm trying to capture this Venn diagram as a tree diagram. Are you with me? The moment you have a tree diagram, it is possible to talk about search operation along a tree. BDS, BFS, DFS, all that is possible. So we are trying to make more mathematical so that we can do some computation. Not only that, these are 2D representations, whether it's tree or a Venn diagram. But I would prefer a linear expression. So what do? I make use of this open and closed parenthesis. The 1 is encompassing everything. So I just open 1, then close 1 at the end. Look here, this open 1 contains 2, 3, and 4. Because 1 contains room 3, room 2, room 3, room 4. The same thing, open 1 has 2, 3, and the entire 4. Inside 2, nothing. So open 2, close 2. Inside 3, nothing. So open 3, close 3. Inside 4, you have 5, 6, 7. So open 5, open 6. Are you with me? So I'm trying to represent that tree diagram as a one-dimensional linear representation. So my first job is to represent a cell as a Venn diagram, as a tree diagram, as a linear representation. So now it is coming under my control. The moment I make it more mathematical, tree-like structure, or a Venn diagram, or a linear representation, it's more convenient for me to deal with mathematics. So this memory computing is giving me a suggestion, an idea, to do the computing of problems. During the computation, we were going sequentially. Whereas here, a cell has many membranes, many rooms. Things can happen parallelly, distributed. So keep in mind, membrane computing is not like Turing computing, where everything goes sequentially, one after the other. Here, things can go parallelly, distributed rooms. In the hall level, and there are many other rooms. Suppose we are given a project, some people doing a project here, at the same time, another room. So distributed are parallel. At the end, they all collaborated, and then the big project is done. So when you do many things parallelly, the job gets done quicker. We have to wait for somebody to finish the job. It goes sequentially. It takes longer time. So when you solve the problem distributed parallelly, time reduces. So that's the idea behind membrane computing. The problem we are distributing to many people and solving simultaneously so that the time is saved. So the empty hard problem now takes a lot of time, whereas here the time is reduced. Let's move on to the example. I give you an example now. This is an example of a membrane computing model. This membrane has got three membranes. The outermost membrane 1, membrane 2, innermost membrane 3. I can draw it like this, represent. In the membrane 1, it is having membrane 2. Membrane 2 has membrane 3. Not only that, the 3 is there. B goes to D, D goes to DE. So there are some processing rules. Inside 3, you have something called AF. One copy of A, one copy of F. Let's understand it. Then A should change as AB. This A should change as B and delta. F should change as FF. So they are trying to say something. This is called the multi-set processing rules membrane structure. This says E becomes E out. That means if you find the E, that should be sent outside the membrane structure. So what are they trying to kind of express here? This is a small problem which is solved by membrane computing. What's the problem? Let's run that. Multi-set, okay. I'm just starting with this membrane computing. Wherever you have a multi-set, there these rules will be applicable. You got time t equals 0. When time t equals 1, these rules will act on this element. When this rule is applied, A will become AB. F or F double F. So when time t equals 1, the AB will change the shape to A will change it to AB FF. So initially this is how it is AF. Okay. Of course, these rules are very much written here. Look carefully. This A, because of this rule, becomes AB. This F, this FF becomes F square. All as a linear. For one of spaces, put F square below. So AB, FF. What about next? In the A now, suppose this rule is applied, A will become AB. Already we have B. And this for each F, we have FF. So next step, A, B square, F. What will be next step? Can you guess? Yes. So you find that F is multiplying, increasing. Suppose the cell decides to apply this rule in the rule, second bucket. A goes to B delta. Now, so the moment the delta was applied, the whole membrane will be dissolved. Let's see what happens here. So, it's progressing this way. What next? What happened? So, in the A one, this rule is taken as a cell. And I know the A will become B. Already we have 3 copies of B. When this rule comes, one more copy of B is added, and this 8F will become 16F. Get the cell membrane, the membrane 3 is not there. That means this rule, A goes to B delta, the delta rule will dissolve this membrane. Now what happens? In this membrane 2, there are these rules available. B goes to D, D goes to DE. So they will start functioning on this multi-set. So the B will become D. This D will become DE. Let's see what happens. And the double F should become single F. That's what it's, the double F should become single F. So, now F when one F is there, F goes to delta. That means this membrane will be dissolved. And now we have only one membrane, and now this rule will start acting on this one. It says that the E should be kept as E, but should be sent out. Apparently, the 16E will go out, keeping this. And now for this There's no more rule applicable here. It stops here. If it stops, I get e power 16. Suppose I go further, I may get e power 32. If we keep going further, it may stop at e power 64. In fact, this example computes the power of 2. Had I stopped before, would have given only e power 8. Had I stopped much earlier, it would have gone e power 4. So this is an example that generates powers of 2. E squared, e power 4, e power 8, e power 16, e power 32. So this is a simple example how a computer is made to generate powers of 2 with a membrane computer. Example 2. Look at here. This is an example where I choose m to be 3, n to be 2. The rules are applied here. I am given a multiset in the room 2. A, B, Q, C, Q. Just keep looking at that one. And so when you find it A, B, it should reduce to A. Or A should become delta. It's a priority rule. When you find the A, B, give priority for that rule. And C must become a C, a D. But C should be kept here, D should be sent out. So let's start. So this is starting. I start with A, B power 4, C cube. These two ABs will become 1A. These three C's will become 3 C's and 3 D's outside. I like on here. Just keep looking at the two. Look at that. You get 3 D's and then you get D and R, it becomes X and sent to room 3. So this is an example that creates multiple X based on the number of copies of A's, B's and C's. They're very simple or toy examples just to say how a membrane structure can work on the processing and create something. If I say that room 3 where I can expect output, undeveloped electron. Suppose I said that I want a room 4, I want the result to be there. It is possible to express the rules that way. Okay. So make it more mathematical. If you can talk about delta tau operation, it is possible to think of many more mathematical operations. Incorporate them in the membrane computing model. So it is possible to evolve many variants. Each cell will be a computing cell, and here you find 1, 2, 3, 4, 5 cells. Let's think of 5 computers connected parallelly. So we can talk about parallel connecting many computing cells, and they can exchange information. So this evolves into developing many variants of membrane computing. Okay, all along I talked about strings, words. Is it possible to talk about numerical problems? Yes, it is possible to think of solving differential equations, LP problems, OR problems with the help of membrane computing. It is possible. And that all brought in the idea called numerical system, where you deal with numbers, equations, not like strings. It is possible. Okay? And then spiking neural system. How the brain neuron cells are functioning. Because a neuron cell will have a specific term called dendrite. They communicate with the brain cells, neurons. So based on the neuron cells, they have developed a membrane cell called neuron spiking P systems, spiking membrane systems. So we get inspiration from various cells. And we need not continue only with the word. We can bring graph, tiles, array as a multi-set. I just give an example. Suppose I have many tiles and I'm allowed to paste glue tiles by this rule. It is possible. Then I can describe some protocol for communicating the tiles. I can develop patterns. Membrane structure. I will have always, instead of the words, I will have tiles color tiles. I will specify how the tiles should be glued, what color should be adjacent. Then I can get patterns generated. And this is a very strange pattern formation. We call it chair-like pattern formation. These are the rules. And you find that this structure is taking such graphs as multi-set. Then they make them multiple copies, they rotate them, tilt them. So you can bring in geometrical operations. Rotate, reverse, all that. It gives, and then it attaches. It makes many copies, it attaches. So you get a new pattern emerging. It is possible to generate such patterns. So the memory computing is more powerful than the query computing because it can do parallelly, distributed, it can solve it. So looking at the cell, they talk about memory computing. The same way how the DNA strands they join and produce, it's called DNA computing. How does the brain function? Neural network. Nowadays we have the DNA coming in. So within the cell or DNA or brain, we get instruction to develop new computing models. It's called unconventional computing model. The challenge is that how do we kind of make use of these biological elements of a cell or a DNA or a brain into a lab? It's not biological. The moment you take a cell, it dies. So is it possible to bring these biological elements on our computer table and then work with them? It is still a challenge. So people have developed algorithms, theoretical models. If it's possible to make a living cell compute, we can solve this problem. So hoping that one day we'll be able to have hardware to bring the living cells onto the table. The DNA as a computing cell, computing model. The theory, the study is going on, this is going on. So we have developed very powerful algorithms. When I say we, I mean the community, academic community, at least 30 years ahead of time. But to develop a computer, memory computer, or a DNA computer, it's not that easy. So develop a hardware of a memory computer or a DNA computer, it demands so much of technology advancement, which is 30 years behind. So the theory is fast progressing. To develop theory, we need to have a strong mathematical foundations. So we mathematicians have always an advantage of developing these mathematical models, algorithms, which are ahead of time. When physics is following closely, they'll develop the hardware, they'll develop technology. Once you have the hardware in hand, I think these softwares can really sit on there and we find the revolution taking place. Of course, quantum computing is now fast developing. They have developed quantum computers, at least the lab. So soon we'll have this unconventional computing mathematically and unconventional computers physically. When this computing and computers get together, we get the revolution taking place. So I just want to suggest these 7 references. You need not strain much. Just type memory computing or P page. Google search, you're taken to a website where you have so much of resource material. So with those things, in fact, I had a chance to meet George Bond when I visited Finland. So this was a picture taken about 12 years back in Finland. So I asked him this question, Professor Bond. Sir, do you think we can realize one day this P computer? Because there are so many years passed by, we have seen only the theory, not a real workable memory computer. He gave a very smart answer. When it becomes reality, I will be the first person to buy that memory computer. He didn't say yes, he didn't say no. He was hopeful one day the world will realize memory computer as a reality. The world will realize DNA computer as a reality. The world will realize quantum computer as a reality on a common room like this one. So with the advent of AI, we are surging fast. Probably in 5 years' time, or 3 years' time, or 10 years' time, we'll be having such computers far more powerful than what we are having now. When that happens, all the theory of the Turing computing will become obsolete. We have simply dumped all those books and we have given to new content. So with those words, I want to finish my talk. And if you're interested, you can just contact me. And I have already given my email ID the first. This is the second email ID. So I must thank Dr. Shamila and others for giving me this opportunity. Please wake up. It's over. God bless.
Thank you for your enlightening section and sharing your knowledge, sir. Once again, thank you, sir.
For the kind information of the participants, I'll be reading out the name of the participants and the venue for the presentation. Please make a note of it. There are 3 venues for the paper presentation. First venue, admin block, 3rd floor, AC Seminar Hall. So the following participants need to go to AC Seminar Hall, admin block, 3rd floor. M. Chandra Mohan, Assistant Professor, Bishop Weber College. Jelin Rani J, Assistant Professor, Bishop Weber College. Meghavarna Elilarasu, Assistant Professor, Bishop Weber College. Brigitte Gladys, PhD Scholar, Holy Cross College. J. Arogya Immaculate, PG Student, Holy Cross College. U. Modernisha, PhD Scholar, Holy Cross College. Jocelyn Lavino, PhD Scholar, Holy Cross College. Jarvis Vivin J, PhD Scholar, Holy Cross College. So you have to move to admin block, 3rd floor, AC Seminar Hall. Second venue, PG block, room number 111, P111. The following students, please move to PG block, room number 111. Augustine Anthony L, PhD Scholar, Holy Cross College. Aparna R, PG Student, Holy Cross College. Rajastri M, PG Student, Holy Cross College. Rafaya Hanish, PG Student, Holy Cross College. RTC, PG Student, Holy Cross College. S. Jaren Rachel, PhD Scholar, Holy Cross College. Kavinandini B, PG Student, Holy Cross College. Vinodini, Research Scholar, Holy Cross College. And the following students are from Bishop Weber College. Yes, Wilson Arul Prakash. Yes, Harini. J. Jasmine. J. Sarojini Rutu. Yes, Harini. So you all must go to admin block, 3rd floor. Third venue, PS block, 1st floor, that is the same hall. A. Sharon Miraculin, PG Student, Bishop Weber College. Vijay Bala, PG Student, Bishop Weber College. M.K. Abhishek, PG Student, Bishop Weber College. Gausalya M, PG Student, Bishop Weber College. Dhanraj S, PG Student, Bishop Weber College. S. Anupriya, PG Student, Bishop Weber College. S. Dinesh, PG Student, Bishop Weber College. Edmund Gill Christ A, PG Student, Bishop Weber College. Soundarya K, PG Student, Bishop Weber College. Divakar R, PG Student, Bishop Weber College. Sridhar M, PG Student, Bishop Weber College. Jay Prasanna R, UG Student, Bishop Weber College. R. Evangeline Jennifer, R. Jivita, P. Princey Renita. So you have to be in the same hall for the presentation.
ஏய் இதுல போட முடியாது.
அங்க இருக்கே பிளக் இருக்குல்ல.
சரி நீ மாட்டி தான் பாரு.
சரி இதை
மாட்ட முடியாதுன்னு நான் சொல்றேன்.
அப்புறம் எதுல மாட்டிப்போம்?
மாட்ட முடியாது. பெண்ணை வச்சு குத்தி தான் மாட்ட முடியும்.
ஏதாவது பண்றேன்.
சரி என்னோட மட்டும் பிடிக்கும். ஏ மாட்ட முடியாது. சரி எங்க போனீங்க எல்லாரும்?
ஏதா
கேவலமா திட்டிட்டு என்ன நீ இல்லையா?
Participants, if you have any doubts regarding venue, you can come and contact the MC desk.
but now in recent days there is a huge increase in fever-related diseases. So a huge amount of people are getting affected by fever, which makes them migrate towards hospitals in order to go and get proper treatments. So this makes hospitals overcrowded, and due to that overcrowding, it becomes a place where diseases are easily transmitted to one another. So that is one of the major problem. And talking about the next problem, healthcare workers are also stressed due to this overcrowding. And after that, the third thing is patients are waiting for so long, which is very frustrating in hospitals. And these are some of the major problem statements. Next slide. So for this problem, already the existing methods, in the existing methods there are chatbots. So those chatbots, they only whether they get input as symptoms from patients, and then they only diagnose disease, or they only recommend medications for the given disease. But in my proposed system, my chatbot, it diagnoses the disease as well as it recommends the medications to the patients based on the disease they have. So that is one of the major limitation of the existing problems. Next slide. Okay, so moving on to the proposed methodology. So I have proposed a chatbot. This chatbot, what it does is it gets input from the user, which is the symptoms a patient has. After that, it uses TF-IDF vectorizer. So it is a concept from NLP. In order to understand the symptoms entered by the user, it uses that concept, and it uses machine learning algorithm to diagnose the disease. After that, it prescribes the most effective medication to that patient who has that disease. Suppose if a patient is getting diagnosed with fever, the chatbot recommends the most effective medication. So, in what basis the most effective medication is recommended is that it gets ratings from previous users. So, based on the ratings, it recommends the most effective medication to that patient. And after that, after recommending the medication, after the course of medication, the patients are asked whether their symptoms have been cured or not. If their symptoms are cured, then the patients are asked to rate the medication based on the effectiveness value. So the rating that patient gives gets updated. This is one of the major feature of my chatbot. In existing methodologies, there is not a feature that gets feedback from users. It only diagnoses diseases, or it only recommends medication. There is no feedback system in the existing methodology, so I have added that in my proposed system. Next slide. So this is the workflow. First of all, user gives the input. Symptoms is given as the major input by the user. After that, the chatbot uses TF-IDF vectorizer for understanding the symptoms, and then those symptoms are transferred to the random forest classifier, which is a machine learning algorithm, to diagnose the disease based on the given symptoms. And this random forest classifier, it diagnoses the disease, and it gives the medication. And this medication is given based on the effectiveness score, as I said before. And after that, the patient is asked whether the disease is cured or not, and if it is cured, they are asked to fill the feedback, like they are asked to give rating. If no, then they are asked to consult a doctor immediately. So that is the workflow of my proposed system. Next slide. So, in order to train this chatbot, I the first machine learning algorithm that I trained is decision tree. So the first machine learning algorithm is decision tree algorithm, and the second one is logistic regression, and the third one is the random forest.
சரி ஒன்றும் இல்லை
Finally, the support vector machine. So comparing the accuracies of these four models, I have choose to pursue this chatbot with the random forest model because it has the
very nice work.
மேலே
I would like to ask a simple question, not in the subject wise. Do you think is it okay to analyze our problem without meeting a doctor or without consulting may not work like that. The model is actually trained based on self-record. Exactly. That's what is it. But I just want to clarify one thing. You have asked to fill out the basic details, that means symptoms, like that. Okay, so you have asked in a medical term, but suppose unknowingly any person gives some information, then it will create some problem. But this chatbot is built especially for minor diseases like suppose anyone unknowingly filled that column. Medical terms நம்ம யூஸ் பண்ணும்போது நம்ம வந்து எல்லா டைமே வந்து அந்த டேர்ம் வந்து எல்லாரும் கால்குலேட்டாக இருப்பாங்க. அந்த டேர்மோட மீனிங் வந்து புரிஞ்சிருக்கும்னு சொல்ல முடியாது. Suppose anyone unknowingly fill that column, then what will be? Actually anything use as symptoms other than that if somebody is using a phone close within the environment. Based on these symptoms as can you show me this page? Is it possible? Okay, thank you.
Vijayabala, yes.
Presenters kindly note that you have only 5 minutes for presentation. So quickly present your content.
Good afternoon. Ma'am, my topic is related to the farmers. First, I want to discuss about the agriculture. Ma'am, first of all, farmer is the backbone of our India because the farming is one of the human or the civilization. So on the base we have nowadays the farming was very low down of do not have an unpredictable weather, unpredictable soil types and etc. So on that my origin of my project will be created. My topic is crop yield prediction using machine learning algorithm. Right. Next slide. Ma'am, nowadays the farmers can be facing unpredictable weathers and soil type and water level consumption. On that day, we have founding a machine learning algorithm for the solution for the facing farmers. One of the algorithm used for random forest and CNN 2D. In this, we have challenges based on introductions, challenges in agriculture due to the climate changes and soil conditions. Next slide, please. This is a problem statement. They have not having a certain weather of crop productions, and they have do not have a condition of a climate and soil condition effectively. So we are providing a soil conditions, weather, and water level consumption for this future growth of farmers. Using this, the farmer can gain more profit, and they have achieve the profit with the 6 months per annum. Next slide, please. Using machine learning, we have to choose the two algorithms. One is random forest and CNN 2D map. Random forest is used for crop recommendation. Example, random forest is one of the algorithms that can be search the data set and input given data to compare both of data and given a certain output for the farmers. Based on the output, farmer can be used to plant the seeds based on the available output. I have attached the output screen in the below and second algorithm is CNN 2D algorithm. CNN 2D algorithm is commonly used for image registration and prediction of the images. In this problem, we have been using a disease identification. Example, if any seed having a disease, we have using a CNN 2D, we have identified one of the disease in the particular images. Based on this outcome, the farmer can be used to improve the seeds or change the seeds to improve the profits. Next slide, please. This is the service of model. First service input, the data set can be used to input the pre-processing the images. Next, the user can be give the input that will be match the input to the second stages. Third stage is efficient extraction. Based on the user input, it will be compare the user input and the data set input using the random forest. The fourth stage will be splitting. Splitting is used for if we only have a name like labeled name, so we have to convert the name to a number. On that, splitting can be used for the data splitting and classification. Using this classification, the deep learning algorithm using for random forest and CNN 2D, they're giving a recommendation to the farmers, and last can be performance analysis. The final result will be generated based on the overall classification. Next slide. This is the data collection and pre-processing. Using the soil data and weather data and satellite images, we can make a prediction based on the input and we have already having a data set based on this futures. Next. Implementation and case study. In this India, we have already they implemented one of the mission smart farming project in India. But in this project, some of the farmers do not have any knowledge and any awareness of this application. If we are giving proper guidelines and proper notification for the farmers, they can improve their farming in the India. Because India having a lot of problems in the farming based thing, if we are giving a first step to solve the problem, we use this application for the future needs. Next. This is the output slide. Example, we are a crop name like Magasi and crop type is Rosie and the area is 3. Based on this, we will be providing a pre-processed structure after this process, and downwards we have accuracy with 99.69. Next slide. Based on this, we have a nitrogen value and potassium value and phosphorus and temperature and humidity, pH value and rainfall. Based on this user input, we can give a certain output to the farmers in the next slide. See, this is identifying crop with an orange and yielded process and water level and recommendation urea. Urea is one of the in Tamil town it's called Uram. If land have certain அந்த தன்மை இல்லைன்னா அந்த உரம் போடுற மாதிரி இருக்கும். அதுக்கு தான் யூரியா அவங்க ரெக்கமெண்ட் பண்ணியிருக்கோம். நெக்ஸ்ட் ஸ்லைட். It is a disease identification used of CNN 2D algorithm, we can identify the disease based on the picture. It is identifying the apple in the black dot. It is identifying diseases of black movement. Next slide. It is a challenges and limitations. In the challenges limitation is the formal awareness and adaptations and modern biases and computation constraints. Ethically concerns of the AI-driven farming. Next slide.
Okay, thank you. Wait.
It is my future enhancement.
Okay, have you verified your model with any real-life data?
Yes, ma'am. I was first time I was used real-time data like API tool used for the farmers, and on this I was compare the real-time data and the dataset data that will be giving more accuracy. So I was choose this project for the farmers for the next level of generation.
So I think most of the farmers knows only regional languages, right? How can they use this?
Ma'am, I was planned that we give you a demo session. Like Zio, they launched the SIM. They give you a free demo session, and they launched the SIM card. That like I will give a free to farmers demo session, and they understand to learn the process.
So first you have to mobilize this.
Yes, ma'am. That is my next future enhancement. First of all, I was developed this in the research project. They guided me. In future, actually, you make a mobile application. Now give you our concept and accuracy level and the accuracy.
So how many real-life data you have verified this?
Ma'am, in this data set, it's normally having 10,000 to 20,000 fields in the data set. I actually using 70% of testing and 20%, 30% of training. Based on
How many of you use this?
10,000. 10,000 fields.
10,000 data sets already existing, right? How many of you have
100 வந்து real time 100 வந்து அந்த
எத்தனை real life data நீங்க யூஸ் பண்ணி ஃபைண்ட் அவுட் பண்ணிருக்கீங்கன்னு நான் கேக்குறேன். ரியல் லைஃப் டேட்டா நீங்க சொல்றீங்க. அது வந்து எத்தனை ஏரியாக்கு ரெஃபர்
இல்ல API டைரக்டா டெஸ்ட் பண்ணி வருது. கிளவுட்ல இருக்கும். அந்த கிளவுட்ல இருக்க API டைரக்டா டெஸ்ட் பண்ணி கொடுக்கறதுனால எவ்வளவு அது அக்யூரேட்டா சொல்ல முடியாது. Based on the job work on the it is only a research project. I will next step I will survey the farmers to implement the criteria and I will modify this certificate.
So after using this for a real life situation, then only you can say this one is good, correct?
Yes.
Thank you. Next one.
M.K. Abhishek.
Good afternoon everyone. I am Abhishek from PG Computer Science. I am excited to share my research on dynamic analysis and detection of API vulnerability using machine learning. APIs, also known as Application Programming Interface. They connect our apps, power our cloud services, and make our digital world more seamless. But growing layers on APIs, threats also increasing. Hackers are constantly looking for vulnerabilities to exploit, whether it's stealing data, manipulating information, or even shutting down servers. That's a serious problem. My solution to this problem is to real-time monitoring the data flows over the internet. The existing system uses static method, which means it checks on the only code, doesn't run the code in a real-life system. It just check the code structure and check whether it's correct or syntax is correct. But my proposed system checks after when active system, whether it's actively in use and able to exploit it. Dynamic detection system. As I said, during an API, when it's live, we used to check on it and check whether it is vulnerable or not. a sample. Here you can see user trying to enter the credentials, username and the password. Password is wrong, so it says an error, email is wrong. Now hackers use a special character in the password field. You can see single quotation. It will cause the server to crash because you can see in the syntax it has double single quotes. It will cause the system to crash. Hackers will use this method to overcome the system and get login into your ID. See, they use a particular malicious code r equal to 1 equal to 1. Hence, they get access to your account. They get access into your account. This is not possible nowadays. They have sanitized it, but we can still do it with increasing APIs. We can still exploit it more different ways. To correct this, with my solution, my process was collecting data collection, future engineering, model training, and evaluations. An API call, when we click the login button, the particular API is called a link. I will get some metadata to us. Metadata is data about data. We use the metadata to get some information about the API call, like the response time, how long it takes, how many size it returns, and status codes. It's particular for the response computer science terms. Those metadata contain status codes, authentication type, result methods, response time, and response size. These data contains more irrelevant values too, like when time made, from which year to which year, type of modification made. These are irrelevant columns. We will mostly drop these columns. I use CNN and random forest algorithms, which are machine learning algorithms, to find out, to train a model to find efficient answer. I use 80% of collected data as a training set and 20% for testing. Evaluation metrics, same as accuracy, precision and recall, and FN score. Output for random forest model and CNN model. Random forest mostly performs better because you can see it gives 100% for severity and error patterns, whereas CNN gives reduced for severity 90% only. As for test accuracy, it gives higher percentage. So, in conclusion, when we compare different models, random forest constantly delivers most accurate and reliable results. For future enhancement, we can deploy this in the real time. Every single time the API is called, we are about to check whether it is correct or it's a malicious system or something else. Thank you.
Actually, the proposed model or methodology to secure our data, right?
Not data.
Yes.
Any kind of internet attacks to prevent from this. Attacks. இந்த மாதிரி malicious lines யூஸ் பண்ணி ஈஸியாக லாகின் பண்ண முடியும். அதில் வந்து ப்ரிவென்ட் பண்ணுறதுக்காண்டி அதை யூஸ் பண்ணிக்கலாம். இப்போதைக்கு பண்ண முடியாது. இப்போ அது இன்னும் டெவலப் ஆயிடுச்சு. ஆனால் அது டெவலப் பண்ணனால இன்னமும் ரிஸ்க் அதிகமாகிடுச்சு. அதனால டிஃப்ரெண்ட் வேஸ் புது மாடர்ன் சொல்யூஷனுக்கு மாடர்ன் ப்ராப்ளம் டெவலப் ஆகிட்டே தான் இருக்குது. அது ரியல் டைமில் டேட்டா
How can you say that your methodology or your proposed model is unique best one?
Not the best one. It's my own idea. Like with my previous ideas.
Have you verified this with any page or? Have you verified it? So எந்த அளவுக்கு வந்து செக்யூர்டா இருக்கு, அதாவது எந்த அளவுக்கு வந்து உங்களோட குட் அப்படிங்கறத வெரிஃபை பண்ணிட்டீங்களான்னு கேக்குறேன்.
Intern
Anyone can propose a model, right?
I have went to intern developing company. They have used APIs for their full projects. I have tested them with their live service. Pretty well. Best சொல்ல மாட்டேன். It's work பண்ணுது. இந்த மாதிரி எக்ஸிஸ்டிங் எதுவும் இல்லை. ஸ்டாட்டிக் மெத்தட் தான் யூஸ் பண்ணுறாங்க.
Kausalya M. algorithms. Next slide, please.
So you have proposed a model to predict Alzheimer's disease.
Not
in the
not
earlier stage.
Alzheimer for machine learning. It's used for predicting in earlier stage. But in my work, I used to compare all the four algorithms.
So already several methods are available. Models are available.
Yes, ma'am.
Okay.
I compare these four models and I show which is the best model with more accuracy.
So we have done comparison study between four different
Yes,
algorithms
ma'am. Between
and
four.
suggest best one. Okay.
Yes, ma'am. Kind of.
So which one is best?
In my work, gradient boosting gives most accuracy value, ma'am. It's based upon the data sets I am given to the system, ma'am. If I give larger data sets to the system, means some algorithms give more accuracy, ma'am. Based upon this, if I give Navy based upon that, in medical images there is not future independence assumption is available. So Navy base give the less accuracy. If I give in another model, another problem means it gives more accuracy, ma'am.
Which type of data you have used? Real life or secondary data? Primary or secondary?
Not like primary or secondary data. I collect from the internet, ma'am.
Then it is secondary.
It's secondary. Thank you.
Dhanaraj, yes.
Good afternoon, everyone. My name is Dhanaraj, coming from Department of Computations, Bishop College. My project title is lung cancer prediction using machine learning. I used algorithm is gradient boosting with three comparison between algorithms using steps. First, fifth slide also. Three algorithms, gradient boosting with three extent algorithms as a steepest gradient descent. Next algorithm is stochastic gradient descent. Next algorithm R-prop gradient descent with comparison. What is high accuracy in three models? This is my project. The need of enhancement diagnosis, early key prediction. Lung cancer is leading case of deaths. Limitations of treatment methods is low error because traditional methods. Objectives and motivation. Machine learning based prediction. Prediction cancer presence. Classifying cancer predictions into low, medium, high categories. Improving clinical decision making. This time, before clinical not used AI uses extra environment is not in the clinic in higher hospital only, high level hospital only. Scope and purpose. Gradient boosting and R-prop is at patient data percentage processing, automated decision support. Methodology overview, data processing, testing and training and testing, performance evaluation, data processing, handling missing values, encoding categorical data and future selections. Training and testing, data split into 70% and 30% for testing. Performance evaluation, accuracy, precision, recall and effort score are used to final the algorithms model accuracy. Dataset categories. Patient records, 1,000 records collected from the Kaggle dataset. Key features: age, gender, smoke. Next, genetical risk factors. Key categories: risk levels and categoricals as low, medium, high orders. Futures and engineering and selections. Future selections: irrelevant data to remove the improving model efficiency and accuracy, improving features. Smoke testing, genetic risk, and air pollution are identified as key features. Data transmission, categorical data is encoded and numerical features are normalized. Performance comparison gradient boosting algorithm. Steepest gradient descent. Average resistance 96%, average recall 96%, average F1 score 96%. Stochastic gradient descent. Average precision 95%, recall precision 95%, F1 score percentage 95%. Orthrop gradient boosting. Average precision 97%, average recall 97%, average F1 score 97%.
What is mean by F1 score?
நம்ம கொடுக்குற டேட்டா செட்டை வந்து மொத்தமாக கால்குலேட் பண்ணி கொடுக்குற F1 score தான். அக்யூரசி நம்ம கொடுக்குறோம். ரீகால் வந்து நம்ம கன்வெர்ட் பண்ண மீதி இருக்கிறது மட்டும் ரீகால் பண்ணி கொடுக்கணும். இந்த எரர் அது மாதிரி பண்ணுவாங்க. F1 score facing first score. First answer. Accuracy.
So we have done a comparison.
Model accuracy வந்து steepest gradient descent 95.67%, stochastic gradient descent 95%, orthrop gradient descent 97%. Is better than orthrop.
So you have suggested one method which one is more accurate.
Much more accuracy.
Okay, so based on this, can you develop a new one? Is it possible?
It's not possible.
Then why didn't you do it? You have done a comparison study only, right?
Yes, ma'am.
Or you have developed anything?
Comparison study.
Okay, so I just asked, why didn't you do the same thing? Why didn't you develop any new model or new methodology? Okay, have you verified so for how many data you have used?
1000 data. In calculate data.
Okay, thank you.
Thank you.
Anupriya, yes.
Good afternoon, everyone. Myself, Anupriya from 2nd MSc Data Science, Bishop Hebrew College. First of all, I overview my project. My project title is a Computations, which is generated by GAT printer, a predictive analysis. I have compared with the existing and my proposed algorithms. Move to methodology page. Next. These 4 algorithms that I have used, and random forest gives me more accuracy, better than these 3 algorithms. Next slide. After the prediction takes place, the result shows the predicted disease, and the database stored in a SQL library, which is helps to train the model again and again by using the storage of the symptoms that the user enters. Next. Random forest algorithms follows a conditional probability of mathematical modeling. This is a comparison of accuracy. Decision tree gives me 85%, random forest give me a 91%, KNN give me 84, and Nameways gave me 81. Before my existing model doesn't have a accurate. They didn't use these algorithms. They just trained the model and gave that accuracy to 75 to 80%. I have used these 4 models to prove that this is a model is good enough to predict the disease. Next slide. This confusion matrix shows the 4 algorithms.
This is the precision and recall performance, which is precision, which shows true positives, and recall, which shows overall the positives that takes place. Next slide. This is a error distribution analysis of my project. Next slide. Comparative analysis of my existing methodologies. Next slide. Next. Conclusion. Future scope. My future scope is to get DRS tablets, to predict accuracies achieved, to predict breathing or all those from the sensor tables, and then combined with this models, they will give more accuracy to prove.
So we have developed a model, right?
Yes, ma'am.
Okay. How can you compare your proposed model and then previous existing model? So you have said the existing model gives 75% to 80% accuracy. How can you say that? Is there any other study previously?
Yes, ma'am. They have already proved that it shows a 70 to 80% from their results.
Okay.
So, but they didn't mention these 4 algorithms only tested like that and all. They didn't inform us. They didn't give that, ma'am. I have used these 4 algorithms to prove this is more better than that existing model.
How can you prove that your model is gives more accuracy?
By using random forest, ma'am. Random forest algorithm.
Have you verified with any data sets?
Yes, ma'am.
Have you used your model with any real life data?
No, ma'am. Just now I did my project.
Better to work with real life data.
Yes, ma'am.
Then only we can identify or we can conclude which one is better.
Still now I didn't publish outside, ma'am. Now only I did project. I have used somewhat it's a collaboration of the synthetic data and real time data. I have used in this data.
So you have mentioned in one slide mathematical modeling. In which part you have used mathematical modeling?
Random forest. 4 algorithms also have a mathematical modeling. By using conditional probability, random forest use this accuracy. We can prove by mathematical modeling also this accuracy.
You can prove your accuracy level with the help of modeling. Dinesh B.
Good afternoon. I'm Dinesh from Department of Computations. I would like to present my research on retrieval prediction using deep learning. So retinal diseases are happening in your retina. There are many diseases such as diabetic retinopathy, glaucoma, and age-related macular degeneration, which cause blindness. So you have to detect that early and to treat it. So in the existing traditional practices, there are manual detection only, so it's known to be human error, and it highly dependent on the expertise of ophthalmologists. It is inconsistency and subjectivity, especially in high volume into settings. Next slide. So the primary goal of my project is to develop an efficient and deep learning based system for the classification of retinal diseases. So basically, you have to upload your retinal image, and it will detect if you have any retinal disease or not. Yeah. Next one. So these are the methodologies I used to develop my research: data collection, data pre-processing, feature selection, classification, and evaluation methods. Next. So for data collection, I use the internet as a source. So you collect the data and resize into 2 to 4 by 2 to 4 pixels. These are the sample data. Next slide. For data pre-processing, I use 3 techniques. augmentation, which will handle any real life dynamic data. Some real life data have some minor rotation or minor brightness, so we handle using data augmentation. For normalization, we used to change the pixel values to 0 to 1. It is easier for the model to train. And class balancing. So my data set have 4 classes, 4 of resistor and 1 have normal light. Each of classes have different data. So to prevent bias, we handle the class added by class weights using class balance. Next slide. So I used Inception V3 as my base model. It is a deep convolution neural network known for its ability to extract intricate features from image. It was developed by Google, and it is an improved version of its predecessor, Inception V1 and V2. Known for its ability to extract intricate features that make it highly effective specialist such as retinal disease classification, and is also best for medical imaging output. Next slide. So these are the layers of V3. We can also add some custom layer to it. This is actually advantage of Inception V3. So I used the pooling layer to downsample the image, and then dense layer, which have 128 neurons and relo activation, which is also called the activation function. Result. So my overall accuracy is 87%. This is my accuracy chart and then validation loss chart. Conclusion. So by using this model, I demonstrated effectiveness of deep learning for intelligence classification. I has some slight misclassification, so that is the limitation. So in future, I need to expand the data set and then I explore other architectures. I incorporate interpreting techniques. That's all.
You can develop your own model.
I use from base model as Inception V3. It is pre-trained, but it's not implemented in retinal disease prediction.
Okay, what is the advantage or what is the uniqueness of using this kind of?
We can add more layers to it. In ResNet, we don't have that independent. We can add some custom layers to it, and it's also used for medical imaging.
Is there any existing models?
For retinal imaging.
The same one?
Yeah, it has some. For retinal disease prediction. Retinal disease. It has some existing model, but it has some low accuracy.
How can you say that your model is unique? In what way your model is unique?
Accuracy. The existing model have some.
What is the accuracy level of the previous existing model?
70 to 80. I achieved 87%.
How can you calculate that level?
Accuracy level.
Yes.
By training the model and.
For how many data you have?
Each class have 400 to 500. It varies, so I use class imbalance to balance.
Gil Christ.
Good evening, myself Gil Christ from MSc Computations department. I am here to present my research paper on earthquake prediction using machine learning. Introduction. Earthquake mandate prediction using machine learning represents a significant innovation in geoscience, providing advanced tool for analyzing subject. In machine learning, I have used XGBoost overview. XGBoost means extreme gradient boosting. It's an optimized implementation for gradient and boosting designed for speed and performance. It works by creating an ensemble of design trees where each tree corrects error from previous one. XGBoost builds a decision trees sequentially. Each new tree is focused on reducing the reducer error, difference between action and predicting magnitude from previous tree. Why XGBoost for this problem? Handles complex relationship between geological future and earthquake magnitude. Robust outlays often present in earthquake data. Built-in preservation reduce overfitting risk. High accuracy due to ensemble learning. Here I have used some methodology like data collection, data pre-processing, feature selection, evaluation metrics. This is a data collection of my research paper. The data used in this study is sourced from the United States Geological Survey. Latitude, longitude, depth, NST gap, CLO, RMS, date and magnitude. Each feature plays a significant role in influencing the earthquake magnitude. The data is used for model training and prediction. Data pre-processing. To prepare the data for modeling, several processing steps are performed to ensure the data is clean, concise and suitable for machine learning models. Data cleaning, future engineering, future scaling. Future selections. The following features are selected for the model based on the relevance and potential impact on predicting the earthquake magnitudes. Conclusion. The static regressor model, which combines multiple machine learning algorithms like XGBoost and random forest, shows strong performance in predicting earthquake magnitude.
Have you developed any field?
Yes, ma'am. In previous paper, they have used random forest algorithm. I have
Just
used
change the
algorithm and accuracy of the magnitude.
Okay. What's the difference? What's the difference you got?
Accuracy. In the existing paper, they have 75% accuracy, ma'am. I have created 82% of accuracy to predicting the magnitude value of earthquake prediction.
So you can predict.
With the help of magnitude value, we can predict the
சரி அப்ப நீ பாத்துக்கிறியா ஆ எத்து
You have to calculate
I have to calculate the magnitude.
based
எத்து அடிக்கிற
on
மாதிரி
the calculation based on any information.
Information which are given by the Sulik. I don't.
Okay.
How many data sets are? 18,000 data sets are taken from Kaggle. Yes, ma'am. Ma'am?
Testing or training?
Ma'am, testing, ma'am.
Testing, how many data sets are?
Testing more than 8,000 data.
For training?
Training more than 10,000. So taken from Kaggle. Thank you.
Next one. Soundarya K.
Good evening everyone, myself Soundarya from 2nd MSc Data Science. Okay, I will just simply conference about it. Okay, so my research work is about the dental abnormality detection. Specifically, we have focused on using a YOLO V5 model. So, can you please move to the next slide? So, main focus is that we will be using the traditional methods. So, the traditional method diagnosis might have some errors, like human errors. In case of accident cases, we will be taking X-rays, but due to the doctor's inconsult things, we might actually lose some point of finding out or detecting the errors in the X-rays. So, my solution is to use the YOLO V5D deep learning model. And I have used real-time data for it, which consists of 800 images. Next slide, please. So let me concise about what is YOLO V5. So YOLO V5 is a real-time object detection model, which is actually a pre-existing model. So here I have specifically used this model to detect the X-rays. So it works with three components, which is backbone, neck and head. So the backbone uses a CNN based concept, and the neck uses the helps to extract the features, and Head part helps to bond the boxes, detecting the parts from the images. So the main advantage is it has a lightweight structure, and also it has a more faster and it has more accurate and precise version. Next slide, please. So we have an existing model of YOLO V5, YOLO V4, CNN based models and the traditional method. So traditional method is that diagnosing the traditional X-rays. So CNN will be working with the flow of early detection and require large amount of labeled training data. And if you look into the YOLO V4, it has a lower precision and recall values. So why I have chosen the YOLO V5 is that it is more accurate and faster in predicting and identifying the detection there. And next slide, please. Can I concise about it? Next slide. So in the results and discussion, I have got a precision of 0.92 and recall of 0.89 and FN score of 0.90 and MAP of 0.89. So here the prediction says about how much it has verified and identified the correct abnormalities, and recall here says about how much overall true cases it has found. So can you please go to the next slide? Next slide, please. Next slide. So this is the result output which we got while testing out. So it has detected the crowning and also the cavities in the upper jaws. Next slide.
Okay, Zina. You have said you have worked out for real life data, right?
Yeah.
You have collected 800 images.
Yeah.
How did you collect it from?
Actually, we just found that real-time data from a cable source where they have collected an 800 image from 10 clinics in Europe.
Existing thing. You have collected from existing page.
We have collected the data from an existing source, but the model we have used is like YOLO V5 is an existing model, but this concept is not an existing one. Like we have just used the new, we have just combined YOLO V5 to predict this one.
Is the new one.
Yeah, this one is a new one.
Okay, so how can we say that this one is unique from the previous or existing?
So I just referred some papers from ICAMBC and they have used YOLO V4 and it shows that the accuracies are less compared to this which we got, and I have mentioned, sorry I have not mentioned the tabular column here, and with respect to the CNN model, it doesn't show the proper accuracy part of detecting and boxing. So it has many miscalculations and misclassification also has been shown in those two models. But when we worked out with this,
you rectified all the things in your model.
yeah, we have just used, so we just had a thought of using YOLO V5 model. What if we use a YOLO V5 model to use it? So this model has given us an output of 0.82, and also we have just verified this output with a clinical doctor, dental doctor, to ensure that whether it is right, correctly predicting the output.
Okay. Okay,
thank you.
Next one, come fast. Divakar R.
அவன் கரெக்டாக வச்சுருவாங்க ஸ்டைலாக பேசுகிறேன்.
You have only 3 minutes, so quickly go to the objective and methodology and final conclusion.
Hello everyone.
Mr. Raman, you are?
I'm Divakar from Computations department. This is my topic, sentiment and dynamics using NLP and time series analysis.
What is the abbreviation of NLP?
NLP and time series analysis.
What is meant by NLP?
Natural language reprocessing.
Learning.
Natural language
Language.
So introduction, sentiment analysis. That means extracting emotion from the textual data. The application within social media techniques machine we use control.
What's your aim? What's your objective in this work? What's your objective in this work? உங்களோட மெயின் அப்ஜெக்டிவ் என்ன இந்த ஒர்க்ல? என்ன கண்டுபிடிக்கிறீங்க? எதுவும் நியூ மாடல்ஸ் யூஸ் பண்றீங்களா?
எதுவும் யூஸ் பண்ணி நான் வேற மாடல் யூஸ் பண்ணி லாகின் பேஜ் அட்மின் பேஜ் மட்டும் யூஸ் பண்ணி.
So you have suggested a new model. Okay. How can you verify that? How can you prove that your one is good or
நியூ மாடல் அவங்க எல்எஸ்டி யூஸ் பண்ணியிருக்காங்க. ஆறாம் மாடல் யூஸ் பண்ணி
பெனிஃபிட் இது யூஸ் பண்றதுனால என்ன ஆல்ரெடி எக்ஸிஸ்டிங் சம்திங் இருக்கு. நீங்க ஒரு ட்ரை பண்ணி ஏதோ ஒரு சேஞ்ச் பண்ணிட்டு நியூவா ஒர்க் பண்ணிருக்கீங்க. ஓகே, ஒரு பர்டிகுலர் அல்காரிதம் வந்து சேஞ்ச் பண்ணி ஒர்க் பண்ணிருக்கீங்க. என்ன அட்வான்டேஜ் இருந்தாங்க? எக்ஸிஸ்டிங் ஓட கம்பேர் பண்ணீங்களா? எந்த அளவுக்கு உங்களுக்கு ஒர்க் ஆகுது?
நான் ஆர்என்எம் யூஸ் பண்ணி லாகின் பேஜ் யூஸ் பண்ணியிருக்கேன், லாகின் அட்மின் கிரியேட் பண்ணியிருக்கேன், லாகின் பேஜ் யூசர் கிரியேட் பண்ணியிருக்கேன். நம்ம போனால்
என்ன பெனிஃபிட் இருந்தாங்க? இல்லை, ஏதாவது இருக்கிறதால நம்ம அந்த மாதிரிலாம் பண்ணுவோம். இல்லைன்னா எக்ஸிஸ்டிங் மாடலே போதுன்னு நம்ம விட்டுறலாம்ல. Why do we go for the new one? Or why do we change? Some reason இருக்கணும்ல. நான் இதை மாத்துறேன் அப்படின்னா அப்போ ஆல்ரெடி ஏதோ சம் ப்ராப்ளம் இருக்கு. ஸோ நம்ம ஏதாவது புதுசாக மாற்றி செக் பண்ணி பார்த்தோம்னா மேபி இது ஒர்க் அவுட் ஆகுன்ற மாதிரி இருக்கும்ல. அதுக்காக அப்படி இருக்கும். Okay, thank you. Next one, Sridhar Young.
Good evening, everyone. I'm Sridhar. My topic is diabetes prediction using deep learning techniques, and the objectives are it early detects the data set. It takes the data sets and I'm using the algorithm to feed forward neural networks.
Early detection means we detect in the earliest stage.
Yes, existing. And it also predicts the severity of the data sets. It implements deep learning for higher accuracy to get better results. Next slide.
You have developed a new page, a new model.
No, in the previous model they used decision tree algorithm. It shows lower accuracy. And
so you just changed the algorithm.
Changed, but in decision tree algorithm only lower data set can be used. But I'm using feed forward neural network algorithm. In that you can use large.
How many data sets you can use in this model, in this particular model?
In this model we can use 10,000, but in decision tree I use 10,000.
1,000.
So it shows better accuracy, and previous in decision tree it was.
Have you verified that? So you said it gives better accuracy. Have you verified that?
Yes, I compared that.
Okay.
Last third slide.
It's okay. Thank you. Next one. Jay Prasanna R.
So, very good evening to all gathered here, especially I greet the dignitaries who are of the dais, and this topic, that is understanding the impact of AI and machine learning in business sectors, and we will be focusing keenly on KNN algorithm. And this title and this research article was authored by myself and an assistant professor from K. Ramakrishna College. Next slide. Introduction. This is the normal problem of the KNN algorithm. This is how the company used to find the data and to analyze the data. And here the final results was the pass P. This is how we find this P by using this formula, that is Euclidean formula. This is the essential thing in this in this KNN algorithm. So this KNN algorithm is the main sub-field of the artificial intelligence and machine learning. So by using this formula, we can analyze and predict all this stuff, and we can easily make our decisions in business. And next slide, please.
What is the need of analyzing all those things? What is the need of analyzing all those things?
That's absolutely a good question. Without analyzing all this stuff, we cannot promote we cannot update our product to another level. It is very hard without analyzing this. In this, KNN algorithm is a very, in upcoming slides, I will be explaining it now. So the objectives, we analyze the KNN algorithm's efficiency in customer segmentation, product recommendation and fraud detection, and we compare the KNN algorithm with other algorithms like SVM, decision trees, and K means first right, and assess the impact of KNN algorithm. Next slide. Next slide, please. So the next slide. Yeah. So the literature review. So these are the literature review we went through to analyze this stuff. So the role of AI in business plays a vital role in the business. So that's what explained by Darren Ford and Ronaki. And next, KNN algorithm is a simplicity and next, yeah. So research methodology. This design is a mixed research design. So here we use qualitative approach and quantitative. Both approaches were used, and also the data was we primarily focused on the secondary data collected by the articles. And next slide. Next slide. So results in customer segmentation. KNN achieved an accuracy of 91% comparing to other algorithms like SVM and decision trees. And also in product recommendation, KNN demonstrated a precision of 89% comparing to other algorithms. And fraud detection. In fraud detection, KNN achieved around 93%, which is significantly higher than other algorithms. So this is why companies are using this KNN algorithm as their analytical tool, and this is why they are succeeding. And next slide.
How did you calculate that accuracy level?
Ma'am, we use the secondary data, ma'am. We use all the articles. So these were the tables, F1 score comparison. In this comparison, customer segmentation and fraud detection, KNN is the toppest, is the highest. And in product recommendation, SVM stands at 90%, and that is used as a very specific algorithm. And next slide.
So you have done a comparison study. So
yes,
amongst all the algorithms,
yes,
you have suggested one of the best one.
Yes, ma'am. KNN is the best. And conclusion: this KNN is very essential and plays a vital role in machine learning, because without this KNN algorithm, machine learning is not at all a possible stuff. And without machine learning, we cannot say a complete AI. I mean, deep learning plus machine learning is equal to AI. And next slide. Next. These are the articles I have referred, and these are the articles which keenly reviewed by me and my author, and we came to a conclusion. Thank you, ma'am.
Okay. We know Dini. R. Evangeline Jennifer.
Good evening, ma'am. My project title is Averaging Intuitionistic Fuzzy Aggression for Decision Supporting System. In this topic, we have two tools, that is computer-based tool and mathematical tool. Intuitionistic fuzzy aggression is a mathematical tool that gives a single input into that gives multiple inputs into a single output. And DS, that is decision supporting system, that is a computer tool that gives analysis and total value. Next slide. Here we are using ANN, that is artificial neural network. Next slide. Here this is an already existing formula that I have changed a small operator.
Why do you choose intuitionistic fuzzy aggregation operator?
And this is my already existing project, ma'am.
You can go with any normal operator, right? Then why do you choose particularly intuitionistic fuzzy aggregation?
And that operator should satisfy some properties, ma'am.
All the operators satisfy all the properties.
And this
particularly, what is the reason for choosing this one?
And simply I modified some values, ma'am, that things which is working. And that is weight, to calculate the weight, ma'am. And here is the formula, ma'am. Here I have changed some operator only, ma'am. They are giving already existing value 1 by n. In already existing formula, they have given 3 weights, ma'am. That is equal to 1. That is 1 by n, ma'am. Previous formula, they give W into mu j, ma'am. That is membership and non-membership. I have used 1 by n. That is weight equal to 1, ma'am. 3 weight equal to 1, ma'am. Next slide. So they are given 3 values for the decision making of changing the formula. So when 3 different values, ma'am. 3 different values means the answer come maximum and minimum, ma'am. I have chosen the operator that gives a single value, same value, ma'am.
Just say any one real life application.
We are choosing a car product and we are analyzing the amount of the product, ma'am. Car price, ma'am. Three different cars and it gives different prices, ma'am. We are analyzing which is the first one, second one, third one. Based on the value, ma'am. Decision value.
Thank you. Next one.
Or Jivita.
Come fast.
Good evening, everyone. Myself, Jivita. I am here to present my topic as an improved intrinsic fuzzy weighted arithmetic average operator for decision support system. So, in this work, I have presented a decision-making model based on artificial neural network using intrinsic fuzzy weighted arithmetic averaging operator. So,
what is the advantage of using artificial neural network?
I am not using the artificial neural network based on based model only I am using here. I continue a future project I am using the in this I am not using the artificial neural network. Based on artificial neural network, this is the first step of only I am using the operator for artificial neural network. I am not using the whole the procedure of artificial neural network. Next slide, please. Next slide. This is the already existing operator now. That is intrinsic trapezoidal fuzzy weighted arithmetic average. In this operator, I am going to implement a weighted. That is, here I have a WJ.
What is the benefit of using this particular operator? So we have already newer operators for taking decisions, correct? Okay. What is the benefit of using this type of operator?
Is there any difference between the unimportant decision already from the system? It will reduce the unimportant based on I have taken trapezoidal decision ஒரு set of values இருக்குமா இப்போ நான் யூஸ் பண்ணிருக்கிறது ஒரு set of values இருக்கும் ஸோ இப்போ இது ஆல்ரெடி யூஸ் பண்ணதுல வந்துட்டு இருக்கிற அன்இம்பார்ட்டன்டான வேல்யூஸ் எல்லாம் இது வந்து ரெடியூஸ் பண்ணி கொண்டு வரும் அதுக்காக இந்த வேல்யூ இந்த புது ஆப்ரேட்டர் யூஸ் பண்றோம்
It is not possible in the previous existing operators. Okay, thank you. Next one.
P10C Rita.
Good evening, everyone. Myself, Presenta from Department of Mathematics. My topic is an improved intrinsic fuzzy weighted geometry for MAGDM model. So I also choose an fuzzy weighted geometrical operator. I have just improved that formula to get that, and I have made a comparative study so that what's the difference between what I have improved and what it had already exists. Next.
And improvised.
Yeah, I have improved I have reduced the weighted value so that from the existed
How can you reduce?
No, ma'am. I have just modified the formula, and then what the result I have get is in the already existed. It has an it gives my data somewhat reduced level, ma'am.
Okay, carry on.
Next slide. Next slide. So this is the already existing formula, and then in this slide, what modification I have did is in the weight value I have subtracted 1 minus the weight value. Next slide. So this is the data given by the data analyst, 3 kinds of data. Next slide. Next slide. This is the output what we have used with the existing model, and then after that, next slide. This is the new formula we have implemented, so that I have what I have read is in this already existing model, the membership value is reduced compared to mine, because in the first already implemented the process, it has a high value of membership value and high value of non-membership value. Using this formula, what I have produced, the membership value is reduced, so that we get a non-membership value increase. So that we can compare that, and we have reduced the membership value, and it gives some exact value.
Can you say that your formula, your own formula is a better one when we compare to the previous?
Yes, ma'am. It has reduced my membership value from compared to that first exist one.
Can we say that it is a better one if we reduce if we get the lowest membership value?
Yes, ma'am. That's what I have chosen this one.
How can we say that? How can we say like that? Membership value lowest value கிடைக்கிறதுனால பெட்டரா இருக்கும்ங்கறதை எப்படி சொல்றீங்க?
Ma'am, comparing to that, it has giving an exact value other than that previously existing, ma'am. So it gives somewhat clear crystal idea. So
have you done any comparison study with the previous one?
Yes, ma'am. First one and second one, somewhat difference is there, so that we have implemented this method, ma'am.
Okay, thank you.
section program.
ஆமாட்டா
சீன்லாம் சூப்பராக காட்டுவாங்க.
ஜகா ஜகா 8 எஸ்பாடா
அடிச்சு அடி அடிச்சு விட்றாங்க.
அப்புறம் கையை விட்டு
அப்படியே நடந்து போயிட்டோம்.
இந்த டைலாக் தான் ஜெகதீஷ்ட சொல்லிட்டே இருப்பேன். யோகஸ் செம்பொன் சாக்குரா என்னாச்சு? அது ஐடி பெண்ணு மட்டும் எடுத்துட்டேன். புரியல. இதுவா காலேஜ் லேப்டாப் எல்லா வசதிகளும் இருக்குது. ஓபிஎஸ் சாஃப்ட்வேர் ஃப்ரீடாண்டா. நம்ம ஒன்றுமே பண்ணிட முடியாது. அவங்க வந்தனால ப்ரொஃபஷ்னலா. ஆனால் என்ன 4:3 ரேஷியோ. இப்போ பழைய பட ரேஷியோ இதோ. ஆமாம் இவ்வளோ தான் இருக்கும்.
2 லட்சம் பேர் எங்கடா இருக்காங்க?
91 பேரா? இங்கே இந்த இடம் தான் பார்த்தேன். லைவ் 2 லட்சம். என்ன சேனல் இது? சேனல் காலேஜா? அப்படியே இல்லைடா.
ஆமாடா ஆடியோ
அப்படியா?
அப்படிதான் லைன் மாட்டுங்க. லைன்ல போய் பாருங்க. லைவ் ஓடிட்டு அவ்வளோதான். அதுக்கப்புறம் Mana wah? Angin நம்ம இங்க வாங்க. லைவை பார்க்கும் 93 நண்பர்களுக்கு பணிவான வணக்கங்கள். நானும் வரேன். பாஸ்வேர்டா அடி விடுவோம். பார்த்துக்கலாம். அடுத்த வாரம் போயிட்டு அடிப்பேன். பார்க்குறவங்க ஏன்னா இது 1803 என்ன அந்த பிஷப் சிம்பிளியா பேசினா காமிச்சிருக்கா? ஆமாம், அதுதானே கேமரா மேன் காமிச்சிருக்கா? அதுக்கு இருக்குமா? இல்லை, நான் இதை எடுத்து உட்காருவேன். மறைச்சி வச்சு பாஸ்வேர்டு உட்காரலாமா? நான் எப்படா டிபிடி போடணும். அவ்வளோதானே செஷன் ஆகும். கல்வி வராங்க. என்ன சண்டை போட தள்ளி போகிறோம். கேக்குதா? எவ்வளோ கேட்குது? ரொம்ப கேட்குது. வச்சு வந்து மேக்ஸிமம் Okay, Manova. Yes, Manova. Do you want it? What?
Good evening, distinguished guests, esteemed speakers, and valued participants. Welcome to our valediction program of the remarkable international conference ICAMBC 2025. Throughout the conference, we have witnessed groundbreaking presentations, engaged in thought-provoking discussions, and forged connections that transcend borders and disciplines. Now let us begin the valediction ceremony with prayer. I call upon Daphne from 2nd MSc A section to lead us in prayer, followed by prayer song by the choir team.
Let us pray. Trust in the Lord with all your heart, and lean not on your own understanding. In all your ways, submit to Him, He will make your path straight. Gracious Lord, we thank you for your love and guidance that have brought us to this moment. As we step forward into new opportunities, we place our trust in you. Grant our graduates wisdom, strength, and a heart to walk in your ways. Bless our college, teachers, and our families who have supported us. May we always seek your will and glorify you in all we do. In Jesus' name we pray. Amen.
Robinson, sir, Head of the Department and Associate Professor of Mathematics, Madras Christian College. I welcome and thank you, sir, for this valuable session. Next, I would like to welcome Dr. Jnanaraj Thomas, sir, retired professor of Madras Christian College, who also delivered a talk today in our conference. I welcome you, sir, and thank you for your presence in this conference. I would like to welcome our Head of the Department, Dr. R.H.Shamila, ma'am. Welcome you, ma'am. And our UG Head, Professor Tilak Moses, sir. Welcome you, sir. And the coordinators, Dr. S. Karthikeyan and Evangeline Diana, ma'am. And my dear faculty friends from our college and the surrounding colleges, and my dear student friends. Thank you so much for being here. I welcome you and thank you all. Coming to the report of the conference conducted today, the second international conference on applied mathematics and bioinspired computations in hybrid mode. On 26th February 2025, that is today, was organized, and in the morning 9 o'clock, the conference began with a formal inauguration session, followed by the guest lecture, keynote address given by Professor Dr. Atulya Nagar, sir, Pro Vice Chancellor Research and Professor of Mathematics from Liverpool Hope University, UK, followed by the next session done by Dr. Jnanaraj Thomas, sir, from Madras Christian College. And then we had a paper presentation session in online, and then in the afternoon session, we had the talk delivered by Dr. T. Robinson, sir. And then followed that, we had 3 parallel sessions in offline mode in various places and 1 online mode in the afternoon session. And now we have come to the close of the conference with this valedictory session. There were 85 PG students' paper presentations which was held yesterday as a pre-conference presentation, and 25 papers were presented today in the online sessions, and 75 papers presented in the offline session today. And totally 185 papers were presented. 8 best papers are selected out of all these presentations, online and offline mode. And out of this conference comes a book published with ISBN number which has 80 chapters. And the book is titled as Applied Mathematical Techniques and Bioinspired Computations, which has titles included in all areas of applied mathematics and pure mathematics as well. That is areas in biology, computer science, data science, engineering, chemistry, physics, especially physics, nonlinear physics papers are there, and a lot of other areas are also present in this book chapters. I thank all the participants and the contributors to the book chapters as well as to the conference. And I wholeheartedly thank everyone who has contributed for this conference. The members are Convener Dr. R.H.Shamila ma'am, our Head of the Department, and Organizing Secretaries, myself, and Dr. Abhinaya ma'am, and Dr. Praveena. And advisory committees with all our faculty members, with our UG Head. I thank you once again for extending your great support for the successful conduct of this conference. Thank you so much.
Thank you, sir. I request Dr. D. Jnanaraj Thomas to share his experience on ICAMBC 2025. Please, sir.
Dear friends, I am very happy this evening because you gained more knowledge on the important topics in computing science, especially applied mathematics and biomathematics, right? So, what is automata theory as well as what is membrane computing? So, membrane computing can also be thought of as an application of automata theory. So, very interesting, and even though you may learn a little bit out of our lectures, so you can keep on reading. That is how we have built okay, our knowledge in different subjects. So you have an advantage of the Google. So if you just put membrane computing, you will get some ideas. So what would be? So you should look into the examples. So from examples, you have to go to definition, right? First, you should always see the example, understand the example well, and then perhaps what would be the formal notion or the definition would be. So perhaps you can think of. So it is, this topic is a very vast topic and very interesting still. Very good research is going on. In automata theory also, we have introduced, two-dimensional automata languages. That's also interesting. That's also growing. So many conferences, international conferences abroad are going on. Okay, so you can, right? You can get more ideas. It is always nice. Okay, and especially I should appreciate, right, the the research practices at workshop. So all of you enjoyed, is it right? I could see, right? Because with a team, how to work, teamwork. Research is a teamwork. So many people give ideas and you have to put into the possible ways so that you can bring a best of order, right? And what we are doing, right? So the collaborative research is very good. And yeah, so actually I appreciate Sharmila madam and her team, okay, who provided an opportunity to you, right? So what would be the new topics to learn? Is it right? Of course, you are studying old topics, algebra, analysis, right? Okay, complex analysis, fluid dynamics or dynamics, right? Like that. You know, functional analysis, topology, all these. But what would be the new areas that you should, okay? So you can perhaps get good right, ideas, and perhaps you can tell to others also. Mathematics is very rich. It's going on. So, very nice opportunity. I think we are thankful to Madam and her team as well as the management, right, principal, the others, for providing an opportunity to talk to you. So we advise Madam to introduce maybe a special paper, elective paper on automata and formal languages. That would be nice. Perhaps she will execute it the next academic year. Okay, if you happen to be here, then you may have a chance, okay, to study this. That is fine. And yeah, so in our college, in Madras Christian College, we have this paper in UG as well as in PG. Right? PG, one compulsory paper and then one elective paper. We have two papers, maybe continuation of the compulsory paper, we have the elective paper. So, yeah, so because yours, your institute is a sister concern, we wish that it should also represent formal language automata theory, right? So we should project it also, because you are all studying subjects, first mathematics and so on. That's fine, but still, if you study this, you could get some papers, right? You could produce some papers in this conference, which are welcome. There is one nice area here, combinatorics on words. That is also a very nice area. So perhaps Fibonacci words, people are working on Fibonacci words, right? and limited words. There are many words available. So this is also one nice area. So these are all coming under formal languages that are that area. There are many topics, new topics available, right? So I actually wish you all the best, right? Because now maybe you have to concentrate on your studies because you are in February, maybe March and April you may face examination. So all the best to you and all the best to the department and department colleagues. Thank you very much.
Thank you, sir.
We felt we are honored by inviting us. Thank you very much.
Now I invite Dr. T. Robinson to share his views on ICAMBC 2025. Please, sir.
And friends in the audience, I joined my colleague Dr. Thomas in congratulating the organizers for making this conference really a memorable one. I'm told that there are 185 papers submitted, then a company of about 80 articles shortlisted and then brought as a proceedings, and then one day full of interactions. I'm sure it is thought-provoking, as mentioned in the introduction. All these efforts started off really well. I think it should be pursued. Those who wish to take up research as their career, or those who want to take up research, I will kind of say a few suggestions. In the morning, your vice principal mentioned about an acronym, MEATH, and said all the 4 or 5 points. I'm not going into that detail, but I just want to say 3 things, just to keep it in mind easier. You can note R. So I want to use triple R, just kind of keep you remember that one. So the first R stands for the relevance of your work. How relevant is your research work? You may be doing any work, but unless it is relevant, it is not looked up by others. Recently, UN has given 17 things as sustainable development goals. There are 17 themes given, spanning across all the disciplines. So if you can identify your research area to any one of the domain, it makes it interesting. So make sure that your research work is relevant to the goal set by the UN. May not be directly, but indirectly it should be relevant. So the relevance is very important. Secondly, the rigor of the research. If you do research just lightly, it may not be appreciated. You have to go deeper into it. So the amount of techniques that you adopt, the amount of depth is very important. So it must be really rigorous. It has to go deeper. Because you spend 3 or 4 years of intensive research, unless it goes deeper, it won't make an impact. So the second point I want to emphasize is that the rigor of the research. And the last thing is, the last R stands for risk. There's always a risk in doing research. Perhaps because of the plagiarism, people quickly copy the work done by others and they don't give proper credit. So there's always risk of your work being copied. So you have to protect that one. So publishing is one important aspect of protecting your work to avoid the risk of being copied by others. At the same time, we are in the world of AI, so everything is now driven by AI tools. And so there's a risk of getting wrong data from the world. There is a scope of, there is something called deep fake. If you rely too much on the AI, we don't know whether it's really true or not. Last semester, with my students, I'm teaching AI to my students. So I was testing the capacity of the AI tools. So for one math problem, we chose 4 different AI tools. we posted the question with proper prompting. We got 4 different answers for that mathematical problem, and all the 4 being wrong. Because we knew the exact solution for that math problem, we could find out what was the mistake. Suppose we did not know the exact solution, we would take any one of the answers. But then again, that is wrong. So, in the world of AI, what is the guarantee that AI gives the correct solution? We don't know. So that's always risk if you depend solely on AI technology or AI tools. So that's why the relevance of your work, the rigor, depth of your work is very important to avoid the risks. So this starting point today, I think will definitely go a long way. As I mentioned, we wish to kind of continue our collaboration. We'll be happy to kind of offer whatever knowledge or experience that we have gained so far. We want to visit your campus again and interact with you. So with all that enriched experience, have a pleasant evening. God bless you. Thanks.
Thank you so much, sir. Now I invite any 2 participants to give feedback about ICAMBC 2025.
Good evening everyone. Myself, I'm Soundarya from 2nd MSc Data Science. So first of all, I would like to thank the organizing committee. Thank you for organizing this wonderful international conference. So on behalf of our department, it was so great to present our research paper here and to also attend sessions of these great presenters like Sir from Madras Christian College. And one thing from our side was it would have been happened in the event planned right as per the time schedule, so it would have been great for us as many of us are coming from long side, so it will be affecting our traveling time. So that's the only thing affected for us. As a whole, it was great for us to attend, and thank you for this wonderful opportunity. Thank you.
Good afternoon to all. Myself Vijay Bala. I'm coming from ICAMBC' Computations. Sir, thank you for this opportunity to conference. Especially the rocket star is given guidelines and he had said a triple R. It's a wonderful, sir. Thank you, sir. And morning and evening session also is wonderful. Basically, we are from the computer science, but I know the maths department and maths knowledge. And if you are in the afternoon, your section is very wonderful. Really, sir. Thank you for this opportunity of the maths department on all the staffs and students for the kind cooperation. Thank you.
Thank you, friends.
Good evening, dignitaries, professors, and friends. I'm Modnisha from Holy Cross College. I first of all thank the organization for providing such a great opportunity. I'm basically a on-stage performance. I'm quite a stage fear type, so I'm totally scared to talk in front of you all. I actually what do I say? This is my very first offline presentation. I was very happy that I at least got a basic guts and confidence to present in front of a huge crowd, and this is my first ever feedback. I thank the organization and everyone. Thank you.
Thank you. It's time to announce the Best Paper Award winners. Vinodini of Holy Cross College has won the Best Paper Award for presenting a paper on the title The Economic Order Quantity Model for Deterioration Impact on the Real-Time Replacement and Various Reorder Points with Imperfect Quality Items. Soundarya K of Bishop Weaver College has won the Best Paper Award for presenting a paper on the title Dental Abnormality Detection. Jai Prasanna R of Bishop College has won the Best Paper Award for presenting a paper on the title Understanding the Impact of AI and ML in Business and Commerce, a focus on the K nearest neighbors KNN algorithm. Audience, please give a round of applause. K. Vinita of Bishop College has won the Best Paper Award for presenting a paper on the title Studies on Adsorption of Acid Grade 87 Dye from Aqueous Solution onto Metal Salt Dope Pani Composite. Brigitte Gladys of Holy Cross College has won the Best Paper Award for presenting a paper on the title Sustainable Fuzzy Rough Multi-Objective Multi-Route Coal Transportation Model with Traffic Flow and Route Constraints. Of Bishop College of 2nd MSc Maths aided has won the Best Paper Award for presenting a paper on the title A New Approach for Alcohol Use Disorder Model with Transmission Rate. Soumya Sarojini B, 2nd MSc Maths A, has won the Best Paper Award for presenting a paper on the title Best Proximity Points for P-cyclic Mapping. Ganesh Kumar Yes, 2nd MSc Maths aided of Bishop College, has won the Best Paper Award for presenting a paper on the title Application of Fuzzy Time Cost Trade-off Problems using Pentagonal Fuzzy Number in Project Management. In online mode, Shanmuga Priya S of Kaveri College for Women has won the Best Paper Award for presenting a paper on the title Interrelation of Generalized Half Companion. Sequences of diaphantine triplets with centered orthogonal numbers. Young Deepika of Holy Cross College has won the Best Paper Award for presenting a paper on the title A Closed Loop Sustainable Protection Inventory Model for Profit Optimization and Carbon Emission Control. Congratulations winners. The other participants of the conference can collect their participation certificates at the registration desk. I invite Dr. Abhinaya to render a vote of thanks.
Good evening everyone. On behalf of PG and Research Department of Mathematics, Bishop Iber College, I am honored to deliver the vote of thanks for the remarkable international conference. We had an enriching and insightful time together over the past few hours, and as we come to the end of this event, I would like to take a moment to express our deepest gratitude. Firstly, I would like to thank our Bishop Commissary, Right Reverend Dr. A. Suresh Kumar Sir, Principal Dr. J. Principal Ma'am, and our Vice Principals in their absentia for their unwavering support towards our department in all aspects. A big thanks to our esteemed keynote speakers, Professor Dr. Atulya K. Nahar, Dr. D. Nyanraj Thomas, and Dr. D. John Robinson Sir, and panelist members. Thank you, sir. Your expertise, thought-provoking presentation and willingness to share your knowledge have made this conference truly exceptional. My heartfelt thanks to our head of the department, Dr. R. H. Sharmila ma'am, UG head Professor A. Tilak Moses sir, and coordinators of our department, Professor P. Evangeline Diana Rajakumari ma'am, and Dr. S. Parthiban sir, for their support throughout this conference. Thank you, sir. Thank you, ma'am. A heartfelt thanks to our participants from various colleges. Your contribution, question and active engagement throughout the session have enriched the discussions. I would like to extend my sincere appreciation to the organizing committee, Dr. P. John Robinson sir, Dr. R. Pravina ma'am, volunteers and staff who have worked tirelessly behind the scene to ensure the smooth running of this event. Thank you, sir. Thank you, ma'am. And also I thank student friends without whom the event won't be success. Thank you all. Finally, I want to thank all of you for your enthusiasm and participation. Thank you once again. Have a safe journey and all the best in your respective fields. Thank you.
Thank you, ma'am. It is my honor to invite Dr. R. Gipchi Shanila, Head PG Research Department of Mathematics, Bishop Weber College, to deliver the felicitation address. Please, ma'am.
It's not a felicitation address. I would like to thank something. So it's இது வந்து நான் வெளியில் அவுட் ஆஃப் த போர்ஷனில் நான் ஸோ உங்களுக்கு ஏன் இந்த கான்ஃபரன்ஸ் நாங்கள் வச்சுருக்கோம் அப்படிங்கிறதுக்கு ஒரு என்ன விஷயங்கிறத சொல்கிறதுக்காக தான், இது எப்படி எமர்ஜ் ஆச்சுன்னு சொல்கிறதுக்காக தான். ஸோ இது வந்து பியூர்லி ஃப்ரம் காட்ஸ் வில் ஃபர்ஸ்ட் ஆஃப் ஆல் இல்லையா. ஸோ வி ஷுட் தேங்க் காட் ஃபார் ஹிஸ் பிரசன்ஸ் அண்ட் கைடன்ஸ். And என்னவோ தெரியல, God has provided me an opportunity to visit MCC Chennai. Okay, so during Decemberல நான் போயிருந்தேன். ஸோ அப்போ போகும்போது I had an opportunity to meet Dr. Robinson sir and Dr. ஞானராஜ் தாமஸ் sir. அவங்க ரெண்டு பேரும் இல்லைன்னா இந்த கான்ஃபரன்ஸ் வந்து எனக்கு சக்ஸஸ்ஃபுல்லாக வந்திருக்காது. So I would like to thank both of them from my bottom of my heart. அவங்க எல்லாரும் வந்து ஆக்சுவலி பார்த்தீங்கன்னா ஒரு கிரேட் பர்சன்ஸ். அவங்க வந்து இங்கே சிம்பிளாக அப்படி உட்காந்துருக்காங்க. ஸோ அவங்க ரெண்டு பேருமே வந்து வெரி கிரேட் பர்சன்ஸ். போத் அதாவது பர்சனலாகவும் நம்ம அவங்கள அப்ரோச்சும் சரி, சப்ஜெக்ட் வைஸும் சரி, தேர் ஆல் வெரி நம்ம என்ன லெஜெண்ட்ஸ் அப்படின்னு சொல்லலாம்ல, அது மாதிரி அவங்க. அதே போல் அதுல்யா நாகர் சார். ஸோ அவருக்கும் நான் தேங்க்ஸ் சொல்லிக்கிறேன். ஃபஸ்ட்டு நாங்கள் வந்து ராபின்சன் சாரும் நானும் நாங்கள் ஒரு வி ஹேட் அ தாட் ஆஃப் டூயிங் த கான்ஃபரன்ஸ். எப்படின்னா அதுல்யா நாகர் சாரை நம்ம வந்து கூப்பிடணும். நம்ம வந்து முன்னாடியே நமக்கு அவர் வந்திருக்கிறாரு, ப்ரோ வைஸ் சான்சலர் நம்ம டிபார்ட்மெண்ட்லேருந்து தான். ஹென்ரி சார், வளர்மதி மேடம், இவங்க எல்லாரும் போய் தான் இந்த எம்ஓயுவே கொண்டு வந்தது. ஸோ அதனால வி ஹேட் அ தாட் ஆஃப் அந்த ஆன்லைனில் நம்ம ஒன்று பண்ணலாம். ஏன்னா நமக்கு பண்டு எழுதுறதுக்குலாம் நாங்கள் ட்ரை பண்ணோம், அங்கெல்லாம் முடியல. பண்டெல்லாம் நம்ம வந்து எழுதி ஒன்லையும் நமக்கு சக்ஸஸ்ஃபுல்லாக வரல, ஒர்க் ஷாப்பும் நமக்கு கிடைக்கல. ஸோ நமக்கு எப்படிலாம் நடத்த போகிறோம் அப்படின்னு சொல்லிட்டு யோசிச்சுட்டு, ஆனால் அவங்க நடத்தணும்னு மட்டும் நாங்கள் பிளான் பண்ணோம். ஸோ அதுக்கு நாங்கள் அவரை வந்து ஒரு பேரை மட்டும் தான் நானும் சார் பேசிகிட்டு இருந்தோம். அதுக்கப்புறம் எம்சிசி போனோன்னே ஐ ஜஸ்ட் ஷேர் த திங்ஸ் about the conference and Atulya Nagar sir to Dr. Robinson sir. He had a collaborated work with him. So he only guided me to contact him, and he only gave me the line to contact him and emailing him like that. Okay, so அது ஒரு கிரேட் ஆப்பர்ச்சுனிட்டியாக நான் இங்கே நினைக்கிறேன் சார். ஸோ அதனால தான் இது வந்து சக்ஸஸ்ஃபுல்லான ஒரு கான்ஃபரன்ஸாக இருந்துச்சு. 3 பேருமே கிரேட் லெஜெண்ட்ஸ் நம்ம கொடுத்துருக்காரு, காட்ஸ் கிரேஸ் அது. ஸோ நான் எப்போ அந்த சீட்டில் நான் வந்து உட்காந்தனோ அது ஐ கேன் ஃபீல் த ப்ரெசன்ஸ் ஆஃப் லார்ட் ஆல்மைட்டி த்ரூ அவுட் த இயர். ஐ ஹோப் ஸோ. ஸோ ஃபர்ஸ்ட்லேருந்து நமக்கு ஒவ்வொரு ரிசோர்ஸ் பர்சன்ஸும் நமக்கு நல்லா கிடச்சிட்டு இருக்கிறாங்க. ஸோ அதை வந்து நான் இந்த இடத்துல வந்து சாட்சியாக நான் சொல்லணும் அப்படிங்கிறதுக்காக தான் மெயினாக நான் வந்தேன். அண்ட் அவங்க 2 பேரை வச்சு வந்து நம்ம நிறைய நம்ம டிபார்ட்மெண்ட்டில் டெவலப் பண்ணுறது நான் ஸ்டாஃப் மீட்டிங்கில் நான் நிறைய சொல்லியிருந்தேன். த்ரூ எஸ்எல்ஓ அல்லது சார் வந்து இந்த ஃபார்மல் லாங்குவேஜஸ் அண்ட் ஆட்டோமேட்டா தியரி பற்றி பேசியிருந்தாங்க இல்லையா. ஸோ அதை ஒரு சப்ஜெக்டாக நம்ம கொண்டு வரணும். அதுக்கு வந்து தே வில் பி த ரிசோர்ஸ் பர்சன்ஸ். ஓகே, ஸோ நம்ம ஃபியூச்சரில் சீரீஸ் ஆஃப் ஒர்க் ஷாப் வில் பி கண்டக்டட் ஆன் தீஸ் ஃபார் ஸ்டாஃப் மெம்பர்ஸ் எஸ்பெஷலி. ஸோ அவங்க அதை குவாலிஃபை பண்ணதுக்கப்புறம் they are suggesting me to include it in elective courses. Okay, so it's a very important topic and so many applications are there. So அதை சும்மா நம்ம வந்து உங்களுக்கு ஒரு ஓரியன்ட் பண்ணணுங்கிறது தான் இந்த கான்ஃபரன்ஸோட ஒரு மெயின் பர்பஸ். So from the bottom of my heart I would like to thank both of them sincerely sir. And moreover என்னுடைய கன்வீனர்னு நான் போட்டிருக்கேனே தவிர நான் இது மாதிரி இவங்களெல்லாம் பேசி அரேஞ்ச் பண்ணதை தவிர I don't do anything in the conference. All the credits go to Dr. Robinson sir because he is the one who has done all the things. இண்டிவிஜுவலி அப்படின்னு நான் சொல்லலாம். நான் கூட திட்டுவேன், ஏன் சார் இப்படி உட்காந்துட்டு இந்த பொறுப்பு எல்லாமே சொன்னது எல்லாமே உட்காந்து அவர் வந்து சின்சியராக அவர் பண்ணிகிட்டே இருந்தார். அண்ட் ஆல் த ஸ்டூடெண்ட்ஸ் ஃப்ரம் ஹோலி கிராஸ் ஆர் எனி அதர் டிபார்ட்மெண்ட்ஸ் ஃப்ரம் அவர் ஓன் காலேஜஸ் இவங்க எல்லாமே வந்து சாருக்காக தான் நிறைய வந்திருப்பீங்கன்னு நான் நினைக்கிறேன். ஸோ அவரோட வேலை வந்து இதில் வந்து ரொம்ப டீப்பானது. அதே போல் அண்ட் ஐ would like to thank the other organizing secretaries, Dr. Abhinaya and Dr. Praveena, for their support, the project support, and all the student friends. I could see all the students friends are helping all of them. So that is the most important thing. It's நம்ம டிபார்ட்மெண்ட்டில் எப்போதுமே ஒரு கல்ச்சர் ஸ்டூடெண்ட்ஸை தான் நம்ம எல்லாத்துலேயுமே நம்ம வந்து அவங்கள மோட்டிவேட் பண்ணி லீடர்ஷிப் குவாலிட்டிஸை வளர்ப்போம். ஸோ அதுவும் இதில் வந்து நான் பார்த்தேன். ஆல் த செகண்ட் MSc ஸ்டூடெண்ட்ஸ் அண்ட் ஸ்டூடெண்ட் பிரசிடென்ட்ஸ் அண்ட் ஆல் ஆர் involved in this. So I am very happy about it. And I would like to thank all the coordinators and the UG head and all the other persons and the staff members who are cooperating with us. Thank you so much.
Thank you, ma'am. I request everyone to stand for the national anthem.
नायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल गंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगल दायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे.
Thank you everyone for your enthusiastic participation. I thank everyone who worked behind for the success of this event. For your information, I request all the participants to come here to the stage for a group photo with the chief